Hey, good morning, everybody. I have 7:30 here in the PAPA broadcast studio. This is Charlie Goodhart. Gary Hoffman's sitting beside me here too. We'll be moderating the session this morning, introducing the speakers, et cetera, et cetera. We are going to get started right at 8 o'clock because we've got a jam-packed, exciting program this morning. So we're just going to let the this PowerPoint cycle for the next 25 minutes. I'll probably come back on in 5 minutes, 5 minutes up, and give everybody a 5-minute warning. But we will get started right at 8 o'clock. That's one thing with Gary and I. We like to start on time, and because we've got a great show today with a really great cadre of presenters. And this is the technical session of the second day of the PAPA conference. First day, of course, was on Tuesday, and we're going to go from 8 to noon, or I'm thinking it's probably going to be about 12:15 that we get done. And we're not going to take any breaks this morning. So get your coffee, get your snacks, get a comfortable seat, and we'll see you back about 5 till 8. And thanks again for attending. We appreciate everybody's support. Hey, good morning, everybody. Again, just giving everybody a 5-minute warning. We are going to start right at 8 o'clock. We've got a jam-packed program this morning. I'm going to start off with as we always do, with safety. Safety first, safety last, safety always. So stand by. We'll be back in 5 minutes, and we'll get the technical session, day 2 of the 61st annual PAPA conference rolling. And we'll be back shortly. Hey, good morning again. This is Charlie Goodhart. We're just doing a little audio check here to make sure everybody can hear us loud and clear. So we're going to get started here in about a minute and a half with with this morning's program. All right, everybody. Good morning. I'm Charlie Goodhart. I'm the Executive Director of the Pennsylvania Asphalt Pavement Association. I'll take this opportunity to say welcome to everybody. This is our day 2. This is our technical session. Normally we would have 2 technical sessions on Wednesday morning, and one would be a paving laydown session, and I would run that, and our Director of Technical Services, Gary Hoffman, would have the plant, the asphalt mix, the testing session also. So we've kind of combined them into one session. Gary is here with me in the broadcast studio at PAPA headquarters here in Harrisburg. And we have a very let's say good. We have a very I think good program lined up this morning. I think you'll be very pleased with everything, and you'll get a lot out of it. So just want to cover a couple housekeeping things before we get started. As you know, whenever you come on to these conferences, just about everybody that's not a presenter is muted. Only speakers will be presenting live. We'll be speaking live. And we're going to ask everybody to hold their questions till the end of the presentation, and then we'll, if you type them in the question pane, it's a drop-down menu on the right side there. It'll say you can see questions. Type your questions in there. Gary and I will keep an eye on them, and at the end of the presenter's presentation, we will ask the question to the presenter. And we've asked each presenter to allow at least 10 minutes to be able to address questions and answers. So note that we're not going to take a break this morning. We've got such a jam-packed agenda. We really are going to go till probably we're thinking at least maybe noon to 12:15 p.m. So please, if you need to get up and take a break, take a break. There will be a little time between between presenters because we're going to introduce everybody. The webinar is being recorded. We will be putting a link on our website, and all attendees will get an email with a thank you email, and it will also include a link to where you can go watch this again if you're looking for more information. So the other thing is we will be issuing 4 PDHs and/or NESEP credits for this morning's session, since it is our technical session. So I just want to make sure everybody's aware of that. So let's briefly, here's the agenda again. We're going to start off with a safety presentation by Rob Ashlaw. I'll introduce him here in just a second. But in our industry, it's always safety first, and that's why we always start every meeting off with a report from our safety committee chairman, or we talk about safety. That's the most important thing for us and our employees. So and you can see we end up the day with a dynamic speaker from the National Asphalt Pavement Association, Richard Willis. I can tell you, you definitely will want to stick around to hear what he has to say about waste plastic in asphalt mix, where that is, where he thinks it's going to go on. There's a lot of pressure from state legislatures, from Congress, for us to help with that particular issue, as we did with ground tire rubber and glass and a number of other products that they wanted to recycle into our mixes. So I'm done talking. We're going to get going with the program. I'm going to take my presentation down here directly. But I want to make sure everybody knows that our regional technical meetings are Tuesday, March 16th and 17th at 8 a.m. and there'll be more information coming out on that shortly. So I'm gonna take my presentation down. I'm gonna make Rob Ashlaw a presenter. So Rob, you can go ahead and bring your presentation up. Let me introduce Rob Ashlaw. He's from Caterpillar. He's from CAT. So his presentation this morning is titled Developing Safety Excellence. And Rob's career experience is in the realm of continuous process improvement across multiple industries, including quarry and aggregates, paving, heavy construction, safety, and including safety and concrete and asphalt supply. As a CPI professional, Rob excelled in implementing projects that resulted in improved quality, safety, and production while decreasing company costs. He is passionate about facilitating teams through rapid improvement workshops where the frontline employees develop their own process activities. Rob has a Bachelor's of Science in Business Administration from the State University of New York, Plattsburgh. So Rob, I'm going to mute my audio. I'm going to take my video down. And thanks for doing this, and welcome to PAPA.
Thanks, Charlie. Appreciate the introduction. Can everyone hear me on the screen and see my PowerPoint that's up here? Okay, cool. Yeah, thanks for the introduction, Charlie. I would first like to, I guess, thank you first and foremost for putting this event together. It's pretty crazy. You go from planning something in person, having all the logistics there, to completely, pivoting, changing, delivering it virtually, so your members can still get great content. So thank you very much, Donna Sweeney. Also, phenomenal job setting this up, running, IT test checks, making sure everyone has exactly what they need, their presentations on there. This kind of stuff doesn't go super smoothly behind the scenes, but as long as it goes smooth, to the people that are viewing, that's the goal, right? Everything's not perfect except for the mat at the end of the day. As long as the grade's right, density's right, everything's good. So I'm going to talk about bringing safety from the corner office to the front line, just a few principles that we live by at Caterpillar Safety Services. I used to really enjoy speaking events, right? You would go get a week away or a couple of days away from home, and your biggest worry was, all right, I got to have my clothes ironed, I can't spill coffee on my shirt in the morning, and I can't have too many beers at the hotel bar meeting some of the attendees at the event. Yeah, and now it's a little bit different. We got to make sure internet connection's good, my dogs aren't going to bark, my lighting's good. It's just a whole different dynamic of what you have to worry about. But the beauty is, back in the day, that the people is what was important about these conferences: the collaboration, the networking, building a relationship with someone, maybe even from a competitor. All of that is the best part of the conferences. Usually not the presentations that are being given, right? It's all the camaraderie in and out of them. So I hope you guys take a few items, nuggets from my presentation. Like I said, it'll be a little bit condensed version just because of the time. But yeah, I'm really looking forward to sharing some of our best practices that we have at Caterpillar Safety Services. So as Charlie mentioned, Rob Asphalt, started my career as an asphalt raker about 10 years ago. Maybe a little bit over 10 years ago. And I remember my very first day on the job like it was yesterday. I'll never forget it. And I won't forget it for a couple of reasons. Those reasons are, so I show up, I'm a young, 19-year-old kid, think I'm invincible, ready to go. I'm a construction worker now, right? I got my fresh steel toe boots on. I got a really clean vest, really clean hard hat. I'm working for a group up out of the Northeast, really big construction group, and I'm thrilled. I'm excited to be there. Show up early, 4:45, supposed to be there at 5. I show up at 4:45. Leave my lunch right in the car. Never been on a construction crew, asphalt crew. I thought I was a badass, essentially, a construction worker, building America, right? And my foreman came up to me right before we started to leave, and he just said, I have initial instructions for you. Whenever you hear us yell DI, I need you to grab this steel plate. I need you to take it off the side of the paver, set it over the drainage infrastructure. We're going to roll over it. The material is going to go on top. You're going to shovel it off quickly as it's still hot. I want you to grab the loop, have a nice slope going into it. You know, make sure it's nice and smooth, not too steep. And I'm sitting there nodding my head, yeah, I can do that. Yeah, that's no problem. And he goes, you know, and then when you're done, pick up the plate and put it back on the paver. And forgot to add the side note of the paver is going to be moving the entire time, right? So I'm like, yeah, I got that. I can do that. No problem. No problem. So about, I don't know, 15 minutes in, we're in a neighborhood. So yeah, I hear the DI yell from the paver operator, and I grab the plate off the side of the paver, smile on my face, probably just like right now. Set it down over the drainage infrastructure. The paver goes over. I'm scooping the material off as quickly as I can. I get the perfect loop. I go to pick up this steel plate, and I don't know if anyone on this call has had the luxury of performing this task. But I'm leaning this heavy steel plate against me. My arms are burning. My forearms are getting burnt. My vest is getting covered in asphalt. And I'm running to the paver as quickly as I can, because every second that I, continue to hold this plate, my arms are burning. So I put it on there, and I'm just looking at myself. My clean vest is gone. My gloves are sticking together already. And I'm like, wow, thank God that's done. And I couldn't even get back to my shovel on the back of the screed. And I hear DI again. And I'm like, oh no. So I go grab the plate that's still hot because there wasn't enough time for it to cool down. Put it down over the next drainage infrastructure. Do the same thing. Do the same thing. Do the same thing. By lunchtime, so 11:30, I think I had done 17. That was the number that I remember in my head, 17. And so I look at the foreman. I'm like, hey, when do we go back to the truck to get lunch? I packed my lunch today. He goes, yeah, that's 3 miles the other way. We're not going back. We all bring our lunches on the back. And I see cans of SpaghettiOs and leftovers from the night before warming up on the back of the paver, because, well, that's a trick of the trade. And if you haven't been in the dynamic of this work, then you wouldn't know that. So I go without lunch that day, and about 6 hours later, on the 28th DI, we were in a neighborhood, like I said, in Camillus, New York. I go to do the exact same instruction as I received at the beginning, right? Put the plate down. Meanwhile, I'm not moving as fast. I'm not smiling. I'm covered in asphalt. I'm hungry, and I go to pick it up. And one of my colleagues, he wasn't my colleague at the time, but one of my colleagues came over and said, "Hey, Rob, if you don't know how to do something, maybe you should just ask." And I said, "Well, what do you mean I don't know how to do anything? This is the 28th one that I've done today. I think I'm doing all right." He goes, "Yeah, watch this." And he puts his shovel, he goes, "Put your shovel underneath the plate and clamp your thumb. And you don't have to lean it against you. And you see those burn marks on your arm? You won't have those at the end." I had a look in my eye. I think that he felt too, because I was about ready to swing the shovel in the steel plate at him. But it just goes to show you, like, I don't know if anyone else, if that triggered a memory for anyone else of remembering your first day of work, or not being told exactly how to do something with clear expectations. But it just goes to show, there's a lot of secrets and tricks of the trade that if you just either ask or you're put on a crew of leaders that want to show you the correct way to do it, you allow yourself to be much more successful. So that's just a little bit of my background, where I started. As Charlie said, I eventually progressed into continuous improvement. And now I work with Caterpillar Safety Services, as I got to see their process from a customer standpoint, and how it changed the culture there. So yeah, getting started. So when people think of Caterpillar, naturally they think of the D11 dozer, D5 dozer, skid steer for whatever it may be. It's yellow iron, right? That's what Caterpillar is known for. Kids have the mini Tonka chair. Like, it's just, Caterpillar is known for yellow iron, and that's because we're really good at it. Some would say we're the best at it. I would say we're the best at it. But what a lot of people fail to recognize is Caterpillar is much more than just yellow iron. It's actually one of the safest companies to work for, not just in the United States, but in the globe. Were we always like that? Was Caterpillar always the safest company to work for? Did the employees that were on the floor, the manufacturing floor, in all our facilities feel as if they were the most important aspect of business? Or did they feel that quality and production and everything other than safety was most important? Well, it depends who you ask. If it was back in the 2000s, early 2000s, and you went out to the floor and you asked these people, what's the most important aspect to your management and to Caterpillar at your facility? The good majority of them we would hope they would say safety, right? Oh, they care about us. The good majority of them were saying production, quality, and then we would ask about safety, and it was like, oh yeah, the banners look good, the t-shirts look good, but they're not. The message wasn't getting to our frontline workers that they were the most important aspect, but we couldn't figure out why. So up on the screen, you have some organizational aches and pains. Now all of a sudden you start to see a lot of buzzwords being thrown around, whether people are revamping their mission statement or, redoing their core values and safety's first. And it's kind of ironic, Charlie also alluded to it. We're starting off the day 2 of the meeting with safety, right? You're starting it with safety. Imagine if we had to say we start the day with production, right? We had to make it a priority and change the way that we think because we had to start the day talking about production. That's not the case because we always talk about production, morning, afternoon, night, because it's one of the core values of our business. But the goal is to make that core value of our businesses, safety, quality, and production, all level playing fields. No one is more important than the other. The items on the screen are common aches and pains within a lot of organizations. And usually, even if you have 2/3 of them taken care of, a lot of people are starting to retain employees better. So employee turnover, you can cross that one off. They're really starting to give out resources and not being held back on a budget aspect. They're making sure people either have iPads out in the field, certain forms that they can fill out if there's a problem. And I believe we're progressing as an industry in the right direction. And that's attributed to supervisor leadership and leaders and executives at the top of the company realizing okay, my heart's in the right place, just like the Caterpillar executives, my heart's in the right place, but how do the people on the floor feel what I want to put forward? How do I express that so they know that they're the most important aspect of what we do every day to people? It seems really easy. It should be really easy, but it's not. So traditional improvement efforts, this is what it usually looks like. This is what it might look like in your organization. And as I'm going through this cycle, a few light bulbs might go off and say, wow, that really sounds a lot like us. So an injury occurs at your organization, hopefully nothing fatal. Management reacts in some way, shape, or form, right? So activities may increase. What does that look like? What kind of activities are going to increase? Or in some cases, on the contrary, activities decrease. I had a gentleman cut his thumb pretty deep, required 6 stitches, didn't have on the gloves, was using a utility knife, and all of a sudden there was no more utility knives allowed in the company. There was a complete activity decrease. Well, on the flip side of that, sometimes activities might increase, and these activities might be more training, because we already don't sit through training at the beginning of the year or when we get onboarded. We need more of that because we're not training our employees. Maybe more audits, because Lord knows we're not doing enough audits to make sure we're safe, right? More compliance, more discipline, programs, more policies, maybe even more procedures, or maybe more safety professionals, because more safety professionals is what we need, because safety is their job, right? It's not our job in the field. It's not our job as operation leaders or executives within our group. It's the safety professionals' job. That's why we hire them. Well, the real key is more of the same is not the answer, because we've been doing this for so long. You begin to fall in this repeated cycle is, okay, incident happened, let's dive into it and figure out why they did it or how it happened. Figure out what little band-aid we're going to put on it. We're going to put everyone through training on how to use utility knives, right? You got to put on the cut-resistant gloves. You got to do this. You got to do that. But then after the injury goes away, it's like that recency bias, right? You forget about it, and it's back to business as usual. The whole no utility knife on the crew. There's usually the token guy. He's usually the same guy you have to remind to tie up your steel toe boots or something, but he has a utility knife in the pocket, right? And then back to business as usual, and you continue to progress until the next injury occurs, and then you fall right back into that cycle. So why do incidents happen? A really, really common example that we give is if I was driving to work today and I was on the highway and there was an accident in front of me, would I attribute that accident to faulty brakes, or would I attribute that accident to like texting and driving or distracted driving, I guess we can utilize now. The other day I'm driving, I look next to me, I'm sure everyone has one of these stories, and you just see, I see a woman putting on her makeup and, you know, drinking the coffee at the same time. And I'm like, wow, that's super impressive. I thought I was a good multitasker, right? But if we ask you that question, I'm hoping all of you are sitting there thinking about it. The answer is that it would be texting and driving 90% of the time that would have caused that accident, not hazardous conditions such as faulty brakes or, you know, something going wrong with the vehicle. So an incident occurs because of that at-risk behavior. And that all stems from the attitudes, beliefs, and ideas of individuals of, hey, I can get away with this, or, oh, you know, this is something that I shouldn't be doing, and you know you shouldn't be doing it. So it can really start to affect the way that they're operating. So I always use the example of texting and driving. So you know, I grew up in a household where wearing a seatbelt wasn't an option. It was just part of our culture. We always wore our seatbelt. I don't know if anyone on this call doesn't wear their seatbelt, or, you know, now in the cars nowadays, there's the ding dong that kind of annoys you to put your seatbelt on. And people do the workaround like buckling it behind you or whatnot. But I never thought about putting on my seatbelt. I still don't think about putting on my seatbelt. It's a subconscious. I just do it, you know. Don't even have to think about it. What I do have to change the way that I've started to operate is, you know, texting and driving. I was always a believer that, oh, I'm a better multitasker. I can get away with doing this. But that was just because I'd gotten away with it for so long. I'd never been in an accident, never gotten a ticket. Like, I was always in good shape. So my attitudes, beliefs, and ideas around a dangerous activity and an at-risk behavior was that, oh, wow, I can get away with it. That's no problem. That's my norm personally, and that stems from my culture, complete opposite of the seatbelt. So I don't think about putting on my seatbelt, but I'll be the first one to answer a text on my phone. So the root cause is truly the culture and the norms that stem from my attitudes, beliefs, and ideas. If you want to focus on the incident after it happens, that's an unintentional and reactive approach. Very common in today's world, but not very effective. If you want to start being effective in growing the new culture and starting a new foundation of making the right decision because it's a safe decision, not making the right decision because, you know what, I'm going to step outside my fault protection zone right now. I've done it a million times. Just going to get the job done and I'm going to go home. When you start to, you know, hold people accountable for the absence of injuries, or for the presence of safety versus the absence of injuries, that's when you really start to see that culture change, right? Oh, I made it to my destination 2.5 hours, and I don't even remember how I got there because I was on the phone, I was texting, I was receiving calls, sending out emails. I need to start holding myself accountable to what was going to make me safer and more successful. So the first step of accountability, which at Caterpillar Safety Services, we believe is the foundation to operational safety success. So you have to have clear expectations for every role. You have to make sure they know exactly what the job looks like and exactly how to do the job well. Much like the DI example that I gave earlier, nobody gave me the tutorial on the tricks of the trade of doing it. You need to equip your people to execute accurately. So whether that's giving them, you know, the tools to do the job or the knowledge to do the job, you need to be able to explain to them, this is why we do it this way, and this is the best way to do it, as we've learned over the years. Those are the two easy steps. Those are essentially the low-hanging fruit of creating that accountability. The third step is measuring performance. So not only are they doing it, but are they doing it well? Did Rob pick up his cell phone on that 2-hour journey, or did he leave it down on the ground? You know, it's a big difference. Maybe turn on the notification that says, I'm driving, I'll get back to you when I get to my destination, which I've started to do now. As my life is progressing, I'm starting to realize that luck's gonna run out, right? And then last but not least, you need to respond with appropriate feedback. So what is appropriate feedback and what does that look like? People often think that going out and finding what's wrong is the appropriate feedback. But if you go out with a different lens on and view something, you know, the positive, and point out like, hey, Rob, great job driving and you didn't text, or example back in the day of me thinking appropriate positive feedback responses was easy, right? I pulled into the terminal and I saw this guy that had worked for the company for probably longer than I'd been alive. He's a bigger gentleman, and he climbed up his tanker to load up with another load to get to the job. And I just pulled into the office and he didn't have his face shield. right? He didn't have his face shield, which is a requirement. So I watched him. I pulled into the office. This is right after we were going through this cultural change, and it was a real emphasis on going and pointing out a positive. And I see him get on the ladder, crawl, come back down. It was, 6 a.m. Go in his truck and grab it. And I thought, there's no better time to recognize someone for doing it right, So I went over to him and I said, hey, it said his name, and he waves down to me. I said, hey, I noticed that you forgot your shield and you came back down to grab it. Like, hats off to you, man. I would have probably just started to load it as it's early. And he looked at me and said, what's wrong with you? Why are you telling me I'm doing something right? And I just kind of laughed, and it was as weird for him to accept a positive recognition as it was for me to give it, right? But the more you do it, the better off you're going to be. So creating that proactive culture, working backwards a little bit, got a couple minutes left. So the proactive culture, so changing those norms in that attitudes, beliefs, and ideas of an individual isn't easy. Changing them in a positive fashion is really difficult, and you have to be intentional and you have to be consistent with it. So focus on those leading activities that you have, all right? Whether it's pre-trip inspections, whether it's, daily safety huddles, whatever it may be, focus on those leading activities, and you'll start to change those attitudes, beliefs, and ideas on a positive note, which will inherently give you some safe behavior. And those positive results are going to come through because you were intentional and proactive, focusing on the beginning of it, the culture and the foundation that you built versus the incident that's happening after it's happened. It's a completely different approach, and it's not easy. If it was easy, everyone would be good at it, right? And people say like, oh yeah, I went out there and shook his hand and gave him a t-shirt, but it's doing it day in and day out when it comes to safety that A, gets really difficult, and B, you're going out of your way and changing your ways. It's like the New Year's resolution, right? I don't know how many people on here have kicked off 21, whether it's going to the gym or cutting out Mountain Dew, whatever it may be. It's really easy, January, February, March, right? You got the momentum, it's new year, new you. And then all of a sudden it's like April, the season's starting to kick off, and then it's like June, and you're getting the call from your foreman at 4:30, whether it's gonna rain or not, and you're like, oh man, I just need a Mountain Dew to get through this day. And all of a sudden you get to the end of the year and you're crushing 12-pack of Mountain Dew like you used to, and you don't even care about it, right? So to be intentional for a whole year, let alone a whole career, changing the way that you guys operate regularly is not easy by any means. So I've given you a lot of different, nuggets, if you will, and I like to be transparent, and at Caterpillar, we try to be very transparent with our customers and partners. This slide right here shows our recordable injury frequency over the years. In 2003, you can clearly see it's pretty high. Global company of about 100,000 people, we're sending home 6,000 workers injured a year in 2003. So we started to focus on compliance and changing the way that we did business and get some of that low-hanging fruit. As you can see, it dropped pretty significantly. In 2009 to 2012, we were plateaued. So we brought in a culture consultant, actually my mentor here at Caterpillar Safety Services, and his group came in and they started to change the culture. It was a family mom and pop owned shop out of Portland, Oregon, which now makes up Caterpillar Safety Services, but we brought them in and changed the culture at Caterpillar in 2011. As you can see, it progressed in the right direction because our management and our leadership started to be a little bit more intentional with how we were doing things. So here are 7 tips. I got 2 more slides and then we'll be out of here. So here are 7 tips, and you guys will have access to this PowerPoint as well. We believe, because we've seen it work and we've seen others, develop and grow their culture utilizing these tips. If you do these 7 different aspects of operationalizing safety, we believe you will be successful. You have to continually diagnose system strengths and opportunities. So ask your people what they think, and don't just ask them and do nothing with it. Ask them and build a strategy for improvement. Let them know that you heard their voices and you're going to fix what they think is wrong. You need to develop leaders, because way too often do we promote the guy that gets the job done the fastest or the quickest. But a lot of times they're not in a position to tell a new hire that, hey, this is the right way to do the DI process. They're more learn as you go, learn on the fly, which works because I'm never going to forget how to do that now. But if you give your people the ability to be leaders and develop them into leaders, you're really going to grow your entire workforce. engage and involve all employees, why not ask the experts in the field how to build a process that they're going to be utilizing every day versus try and come up with it on your own? Demand strong accountability, we talked about that. That's the foundation to operationalizing safety. Integrate active and passive communication. So going over to someone and saying, hey, good job, thanks for doing that, I appreciate it, is that active communication. And then maybe you see it enough from a specific individual and you send something out in your quarterly newsletter. And utilizing technology as an enabler. We have a lot of technology available to us nowadays. We have a virtual reality paving simulator. We have a number of different tools that make life easier, whether it be training, onboarding, growing, communicating. There's a lot of different tools that we have available. If you utilize those 7 different tips, these are the outcomes. Excuse me. These are the outcomes that you'll get, and these are typically the outcomes that every business wants, right? So those aches and pains I put up earlier, if you start to incorporate those 7 tips into your organization, you can start checking them off one after another over the years. The funny part is everyone thinks that changing the culture takes no time and it just boom. But something that stuck out to me, I'm a big sports fanatic, and in 2011, Theo Epstein, the GM of the Cubs, no longer. His opening day press conference, he gave a really intriguing speech to me. He said, I'm going to change the culture and we're going to start to develop a winning culture, and it's from the top down. And if you're not going to buy in, you're probably going to be on the way out. And everyone says that when they're in a new position of leadership and they have the ability to infect change, right? But he really stuck by his word, because in that same year he let go of some household names that other GMs in the league couldn't believe he was doing. But they were more of the me attitude instead of the team attitude, and it's always team over me. So when you start to do that, right, and change the culture, it takes time. It took him in a baseball organization 5 years to win a world championship. So maybe that's an organization of 300 and 500 people, right? Well, a lot of you that are sitting here listening to me right now, you're 3 times, 4 times, 5 times the size of that, with a lot different dynamic of what you're trying to change. So if it took them 5 years, you have to anticipate that you have to do the right things and grow this culture and engage people and develop leaders for a time period longer than overnight and longer than 1 year, where you really start to see the fruits of your labor. All right. On the screen right now, there's a QR code. For those of you that don't know how to utilize this, I'm sure a lot of you now are becoming more accustomed to it as you're going out to restaurants and you have to scan QR codes to get the menu. If you just pull up your camera option on your cell phone, you don't have to have anything else, and you hold it in front of the Scan Me, that'll automatically pop up a link that will allow you to get this presentation, and it will also allow you to have my contact information. I appreciate, once again, Charlie and Donna for putting this together. I'm really looking forward to the future and presenting to you guys in person, and maybe having a couple of beverages at the hotel bar the night before, the night after. But if anyone has questions for me, like I said, this culture transformation stuff isn't an umbrella policy. It's a little bit different for every single organization, but we're here to help. We have a lot of great tools that are available, online streaming services, consultants, and yeah, we're here to help. So I appreciate it once again, excuse me. I hope everyone enjoys the rest of the conference, and I appreciate you paying attention to the presentation this morning.
Hey, thanks, Rob. Rob, I know when you and I first discussed you doing a presentation for at the conference, it was going to be in person, and you said about doing an augmented reality or a virtual reality demonstration as far as what CAT was doing for safety. So, and you mentioned that in your presentation. Is that something you're developing or you've developed? Just a little. Could you just speak about that a little bit, and how you're, is it just for safety? Are you implementing it into some of your other processes? Can you talk just for maybe 30 seconds on that before we let you go?
Yeah, sure. Great question, Charlie. So yeah, so there actually is a couple of groups on here that are utilizing the virtual reality technology already. Caterpillar partnered with the Colas group out of the Northeast, and they developed this safety training for virtual reality, augmented reality. So you put on these goggles, you have 2 controllers, and all of a sudden you find yourself on the side of a heavy highway job. So there's 5 different modules within the entire scenario. You have to set up traffic control. You also have to walk along the side of the paver. You have to bring a shovel over to your colleague on the other side, and there's a lot of little intricacies that are important throughout the simulation, if you will. So just for example, for the people on here, we had we gave a demo, and we had a 30-year employee in the asphalt industry put the goggles on, and he broke the cardinal rule. He walked in between the asphalt paver and the dumpster. And everyone knows that's one of the #1 no-nos that you don't do on an asphalt crew. And in the simulator, when you do that, you get hit by it and you have to restart. And this 30-year-old veteran, 30-year work veteran, said, like, where was this when I started? Because I sure as hell caught a better lesson from the operator jumping off and you know, reaming me out than learning that way than I could have just learned like this. So it takes about 30 minutes to go through the whole simulation. It talks about team lifting. It talks about wearing the correct PPE, and you actually have to put on the PPE yourself. It's super interactive. Yeah, and if people have questions, you know, we're more than willing to either set up a virtual demo or maybe when things relax a little bit, we could come and, you know, deliver an in-person demo so they could try the technology themselves. It's pretty advanced.
All right, well, thanks, Rob. We'll definitely have you at next year's conference at the Hotel Hershey, and we'll tell everybody when you're going to be at the bar so you can buy everybody an adult beverage, let's say, or a Shirley Temple or whatever they like. So thanks a lot for doing this. Thanks to John Soltis from Cleveland Brothers also for lining you up. So we're going to move on. We're going to move on, Rob, and I'm going to turn it over to Gary Hoffman here to introduce our next presenter.
Put the camera. Well, good morning. Most of you are aware of the ongoing national effort to use mixture performance tests for both rutting and cracking resistance in order to balance or optimize our asphalt mixes. We've asked Tom Bennett, Dr. Bennett, who is working with the New York DOT to put their efforts together in this regard towards balanced mix designs and present his work to us here today. Dr. Bennett, who is no stranger to us here in Pennsylvania, is an associate research professor at the Center for Advanced Infrastructure and Transportation at Rutgers University. Tom's research focuses on asphalt mixture and binder performance, performance-based asphalt mixture design, pavement design and rehabilitation, forensic analysis, and recycled materials. When Tom is not in the lab, he can be found at the soccer field or hockey rink with his family. Tom, we're going to turn it over to you. I'm looking forward to your presentation.
Thanks, Gary. I appreciate it. Hope everybody can hear me. Just trying to make sure that people can see my presentation.
Looks good, Tom. You sound good too. We're going to try to do a sound check to make sure, but you sound you've got a good quality audio. So thanks a lot for doing the presentation.
No problem. Again, I'm just trying to find my presentation here now. So that's the only thing that I'm lacking. Can everybody see the presentation?
Yes, sir.
Okay, great. All right, so I appreciate Papa for inviting me back. Always enjoy coming to Hershey and presenting. One of my favorite stops around the winter time. Hopefully looking forward to coming back next year. As Gary had said, what we're trying to do here is look at the balanced mix design concepts for asphalt mixture design. And in this case here, what New York State is doing, they put a lot of time and effort into looking at seeing how they could develop their own research and looking at seeing how they could put this into the specification. So our goal here in the study was to essentially look out, see their mixes, test their materials, and see how balanced mix design could be implemented in their state. moving forward. There we go. Just a quick, some quick acknowledgements real quick. So Zavari, New York State DOT was the manager on this job. A lot of work was being done under these COVID guidelines that everybody's had to work with. Difficult from a university standpoint. A lot of things were shut down. So Ed Wash, Drew Tulanowski, Ed Haas, Chris Erickson, Nick Sidowitz, my staff at the lab did a tremendous job to work quite efficiently and safe during this time. A lot of materials were being produced and tested, so I really do appreciate all of their work that they did during the study. So as we mentioned before, the idea here is balanced mix design, and very simply put, what we're trying to do is determine an asphalt content that will achieve certain performance criteria related to the fatigue cracking performance and rutting performance of the mix. Obviously, we want enough asphalt in the mix to be quite durable, ensure that we meet our fatigue standards, but not too much asphalt where we have stability and rutting issues. So it's balancing the performance is what we're trying to do. And in this case here, what we were looking at was going over a number of different state-approved mixes in New York State and seeing how they compared to their volumetric current optimum asphalt content. Included in that, and it sort of was wrapped into the study, New York State's also looking at implementing some of these IDT test methods, indirect tensile tests, which are fairly quick and easier to implement during quality control testing and some of the more complicated, expensive tests. So they were looking for some performance thresholds. So we'll show you some of that and how that was done. In the end, really what this was a large scoping project for New York State, seeing where they are, seeing how their current materials are performing, and where they need to go from here to see about performance-based mixture design. General methodology of our study, one, we reevaluated all the raw materials coming in, aggregates, wrap, etc. We'll show some of those results. We needed to verify all of the blends and verify the mix design volumetrically before we can move forward. Once the volumetric design was verified, we then produced specimens for performance testing. This is the whole concept of the balanced design. We did it at optimum, then minus 0.5% asphalt, plus 0.5%, and then plus 1% to get this range of performance and see how the asphalt content was changing the performance of these mixes. And then in doing so, based on the performance tests used, came up with these balanced mixture design curves. So in essence, it was, again, a large study looking at a large number of materials across the state. You can see here the map of New York State with their different state regions. There were 11 different mix designs that were evaluated in the study, as far west as Niagara area to as far southeast as to Suffolk. So quite a large amount of materials, a wide array of mineralogies and mixed designs that were taken into consideration. Something that comes up quite often during studies are how do you condition the materials? Because obviously conditioning is important to try to mirror what we would expect to see in the field. At the same time, we want to make sure that we don't spend too much time conditioning, because then that takes away from the normal everyday practice. So there's got to be a happy medium along there. So just look for normal volumetric design and conditioning. We were using Ashlaw R30 to 2 hours plus or minus 5 minutes at compaction temperature. Handling wrap is always a question. How do we handle wrap in the laboratory? And in a lot of cases, if you look through the literature, there are about 5 or 6 different methods that have been promoted. We eventually settled on the methodology that's in Ashlaw R35, which is you heat the wrap up to the same temperature as the aggregates for no more than 2 hours. That's just to ensure it gets dry enough and starts to be a tiny bit workable. That wrap was added after the aggregates were being mixed in the mixing bucket for a few seconds, just to kind of make sure that it was blended, and then we added the asphalt binder to the material. And this occurred both for the volumetric work, for verifying the design asphalt contents, and then also for all the mixture performance. From the mixture performance side, when we were looking again at the conditioning, for the rutting, we took the approach of being a little bit conservative and we only condition it volumetrically. So it was just for those 2 hours that were done during normal volumetric design. Again, depending on location in the country, this may change. I'm trying to mirror the exact aging that occurs in the field. But from a practical standpoint, we thought that this was the best bet for us to ensure that we could get something done within a day's work. On the fatigue cracking side, again, trying to be cognizant of trying to complete the work in a day, we used 4 hours of loose mix aging at 135 degrees Celsius. There is some precedent for this. TTI had done some work for Minnesota DOT on a similar project using the same sort of aging protocol. It does not long-term age the material. It's not going to feel like it's 15, 20 years in the field, but it does provide a level of some aging that will help to induce or at least accelerate some sort of fatigue cracking. So the performance tests that we use, I'm sure you guys are all familiar with the SCB test at this point. TP124 in Ashlaw, I believe now it might be T393. Test temperature 25 degrees Celsius, loading rate 50 millimeters per minute. I'm sure that I know a lot of SCB work's being done in Pennsylvania right now. But the idea here is that we're looking for the amount of energy to fracture this semicircular specimen, and then also look at the post-peak slope. And the inclusion of both of those pieces of information give us a relatively good idea of the cracking potential of the asphalt mixtures. And this test has become quite popular over the past few years. We also looked at the overlay tester. We have a lot of experience with this particular device in New Jersey. New York State likes the concept of the overlay tester. But again, as I mentioned earlier, there are some tests that are a little bit more prone to being time consuming. This happens to be one of them, where some tests could last almost half a day, as opposed to some tests you can complete within 15 to 20 seconds. So as good as the results are in the overlay tester, there are some issues regarding the general time it takes to run this, but still very good results when you compare it to the field performance. And last but not least, we took a look at the fatigue cracking test, the Ideal CT. Again, a much simpler test, easy to run, can be conducted quite easily in the laboratory during quality control testing. And the analysis is almost identical to what we do in the SCB flexibility index test. So fairly easy to run, fairly easy to conduct, and something that can actually be incorporated during quality control. From the running standpoint, we looked at the Hamburg wheel tracking test. This is traditionally used as a moisture sensitivity test, but there's been a lot of work to show that it also has a very good indicator for rutting. Very simple, 50 degrees test temperature we use for New York State, 158 pound steel wheel load and 52 passes per minute, which is really standard for Ashlaw T324. For this particular study, we were just looking at the rutting after 20,000 cycles. That was primarily the main comparative that we used, although there's a lot of information that you can pull off from the Hamburg, such as the stripping inflection point, creep slope, stripping slope, and all these other parameters. We also took a look at the Asphalt Pavement Analyzer, and in this case here was run at 64 degrees Celsius under Ashlaw T340, 100 pound wheel load, 100 PSI hose pressure, and we looked at the running after 8,000 cycles. And then last but not least, we also took a look at the high temperature IDT test. For those of you that aren't familiar with this, this came out of some of the research in the NCHRP Project 933, compares exceptionally well to the Asphalt Pavement Analyzer from what we found in the laboratory. And if you go through the recommendations in there, you're testing it at a lower test temperature than you would traditionally think for rutting, but it does correlate quite well to some of these other rutting tests. And in this case, for New Jersey's conditions, it was 44 degrees Celsius, and New York State also decided to use that test temperature as well for this particular study. So with those 6 tests, we went forward. We started doing our mixture verification work. The mixes that were involved were pre-approved surface course mixes in New York State, 9.5 millimeter and 12.5 millimeter. Wrap contents range from 10 to 20%. The virgin binder, there were 2 binder sources or 2 binders that were used based on the mix types. One was a 64V minus 22, and the other one was a 64E minus 22. But I will say both of these binders were quite robust. If you look at the low temperature grade for both of these binders, they were both graded out as a minus 28. So they were actually a quite robust polymer modified binders for the study. So what we did is each aggregate source, each aggregate type, we verified gradations, gravities, and then we did the same thing with the wrap source as well. We blended them together based on the job mix formula, and if they were off by about 4%, which is close to the QC specs for New York State, we made some slight changes to the blend percentages to get the gradations as close as possible. Wrap content never changed, so if the wrap content's at 10%, we always kept it at 10 or 20%. That was constant, but if the gradations didn't meet the job mix formula, the blend percentages were varied slightly to get the gradations as close as possible. And then optimum asphalt content was verified using volumetrics, and we tried to maintain the volumetrics as close to the mix design. In New York State Materials Method 516, they have a table of guidance as to making sure that your QC results are close to your design results. So in this case here, whenever we were verifying a design, if we weren't within these tolerances, we went back and redesigned the material. This didn't actually have to happen. There was no redesigns. There were some slight tweaks with asphalt content, but for the most part, things matched up fairly well. Here's an example of one of the mixes. You can see this is mix number 7 in our study, and you can see from the chart that, again, this particular mix had 6.1% asphalt, a bulk specific gravity of 2.35 and max of 2.435 during their design, and that matched up rather well and within the limits of what New York State 516 recommends. So all in all, this was done for all 11 mixes across the board. One thing I do want to bring up real quick, and for states that are looking to do something like this, is make sure that you identify that not all wrap is created equal, okay? Again, we had 11 different sources from across the state of New York, and looking at the properties of the wrap, they did vary from source to source. High temperature range from a continuous grade of an 85.5 to 93.1. The low temperature range from a -8.4 to a -20.3. You can see the relative PG grades for those there as well. Asphalt content range from 4.6 to 6.3. So again, you're talking about a swing of 1.3% of asphalt content, depending on where the wrap was across the state. Gradations changed dramatically as well. You can see the range in the number 4 was as high as 90% and as low as about 69%. And then the 200, which we know that generally the wrap is going to have a little bit higher 200 content, was anywhere between 15.5 to 8%. So the wrap does change from across the state depending on your locations, which we would assume based on your mix types that are being used and milled up. Lastly, one of the things that we always want to take a look at is what is the correction factor for wrap. Quite often we determine the asphalt content of wrap based on an ignition oven, but unfortunately we generally assume what the correction factor is for the ignition oven for wrap. We either assume that it's a particular value that we feel is historically appropriate, or it compares well to our mix designs. And in this case here, the true ignition oven correction factor is simply what the ignition oven loss was minus what we actually determined through a solvent extraction. And you can see here that in theory, the correction factor ranged from 0.37 to 1.1. So again, can be quite a wide range depending on the wrap source. It's not all that consistent across the state. Now at low wrap contents, this probably doesn't make a big deal, but when you start getting and wanting to use higher wrap contents, 25% and up, you start to see changes that you're going to have to ensure you take in consideration during your volumetric design, because you're going to be either over or under asphalted based on what you're doing. Performance testing, again, this is where we get back into the mix. So once the mixes were verified, specimens were prepared. All of our mixes were compared between 5.5 to 6.5% air voids. The reason for this is we were trying to mirror typical field densities. And again, all the materials were produced at those 4 different asphalt contents based on the optimum that was determined volumetrically. So in each case, what we had here was at least 4 different asphalt contents, all the same density, and then all these materials were tested in triplicate for averaging. For graphical presentation and in balanced mix design, you have to have a running test and you have to have a fatigue cracking test. And in this case here, what we ended up working with is we just grouped based on general practice for our area. So in New Jersey, we use the APA and the overlay tester. So those 2 test methods were used to develop the balanced mix designs. There's been a lot of work and movement in the Northeast. I know Pennsylvania is looking at something very similar, where you have a Hamburg and the SCV flexibility index test. Some people are also looking at the ideal CT, but we did merge the Hamburg and the SCB flexibility index in that balanced design. And then last but not least, what we're calling the plant QC is a high temperature IDT and the ideal CT. So those two tests can be implemented at the plant. So we decided to call those plant QC. But if you're comfortable with any of your performance tests, then it really shouldn't matter, because they should probably give you something that's very close. If I was to swap out the APA for the Hamburg or high temperature IDT or any of the cracking tests, if you're confident with your performance tests, they mirror what you see in the field, they provide you relatively good field performance prediction, then in the balanced design concept, they should all give you basically the same results. Now, one of the things that I mentioned earlier was that New York State is looking to implement the IDT tests, but unfortunately, they have very limited experience with it. So one of the things that we did is we leveraged the database of performance that we were getting from this study to develop this criteria. And in essence, what we ended up doing was looking at testing all the different materials across the board, 44 different data sets. And what we ended up doing was coming up with trend lines among the different tests. Here's an example of the fatigue cracking tests. One of the things I want people to take away from this is that the ideal CT, the SCB flexibility index, and the overlay tester all correlate exceptionally well to one another. So for a state agency that's thinking about adopting a fatigue cracking test, one out of these three is probably a pretty good idea, because they do correlate quite well. So some states might have seen good experience with the flexibility index. I know we've experienced good performance in New Jersey with the overlay tester, but what we saw, and we're not the only ones to see this, there's a good correlation between these three test methods. And in doing so, what that's allowed us to do is come up with equivalent performance values. So as I show here, the flexibility index value of 8, which was determined by New York State as a criteria, is similar to an ideal CT of 138. The overlay tester of 250, which is what we use in New Jersey, is equivalent to an ideal CT of 141. So when you take the average, it was 139. We did the same thing with the high temperature IDT, and basically what that developed for us were two sets of criteria. The high temperature IDT had to be greater than 30 PSI at 44 degrees Celsius, and then the ideal CT had to be greater than 135. We sort of rounded that down to an even number. So this was the criteria moving in. You cannot go into balanced mix design without criteria. So you have to first develop the performance criteria, make sure that it relates to the field performance, and then you can move forward with the balanced mix design. Without the criteria, you don't have the balanced design method. So just show you some of the results. I'm not going to go through all 11 mixes, but you can get an idea of what we're doing. In this case here, this was mix number 4. This was a 64V minus 22 with 10% wrap. And what we have here is you can see that based on the current volumetric design, these mixes were, or this mix was balanced. So regardless if we use the high temperature IDT work, which is shown on the left, the APA and the overlay tester, which is shown in the middle, and the SCB and the Hamburg work, which is shown on the right, they all were balanced within that design. We saw better consistency with the fatigue cracking tests than with some of the running tests. And honestly, that was really done because the criteria was for the APA and the Hamburg were selected based on general experience. We didn't really correlate those together like we did with the fatigue cracking tests. But in all cases, the running was never a problem. The only time that we had problems were on the fatigue cracking side, which just lets us know that in some cases, we're not getting enough asphalt in the mix to meet our minimum cracking standards. This was mix number 8. This was a 64V minus 22 with 15% wrap. This one here, this current mix is not balanced, as you can see. Optimum asphalt content volumetrically was 7, and we're showing that you need somewhere close to about 7.8, 7.7 to ensure that you have a mix that is performing well in fatigue. Again, running is never a problem, was never a problem in these mixes, but it was generally on the fatigue side. This is another one which, again, is right on the edge of failure. And in this case, one test, the Hamburg and SCB in particular, the SCB showed that it just barely met. If you looked at the trend lines, it comes up with a minimum asphalt content requirement of 6.23. Volumetric was 6.3. The other two fatigue cracking tests, 6.52 for the ideal CT, and then 6.38 for the overlay tester. So This particular mix is really right on the edge of achieving a minimum asphalt content. These sort of mixes, again, you know, because of the way that they're performed and because of general QC tolerances, probably would classify as not balanced, because under asphalting during production could occur and push you just over that line there. And then in this particular one, this was mix number 10. This was a 64E minus 22 with 20% wrap. This one, again, was a very stiff mix. Rutting was certainly not a problem. In fact, in some cases, if you look at the APA in Hamburg, it could tell you could be well over 13% asphalt content. I don't know if you'd be able to actually achieve that, but based on the regressions in there, it says that you have quite a good rutting resistance. The problem is on the fatigue cracking side with this particular mix. When we looked at all the mixes in summary, what we found was that 5 of the 11 mixes were shown to be balanced, okay, meaning that the optimum asphalt content volumetrically was greater than the average minimum asphalt content based on the fatigue cracking test, but below the average rutting asphalt content for the rutting test. So it fell right between that range. 6 of the 11 mixes are currently not balanced. And you can see in here, some of them are relatively close. Like if I look at mix number 11, if I look at mix number 9 in particular, you see that they're very close. And when we consider the precision and bias of just the ignition oven test of 0.33 for multiple labs, you know, those results are probably statistically equal, meaning that you're probably optimum asphalt content and the balanced asphalt content are probably the same. But based on now the results of the fatigue cracking test, we may want to look at possibly including a little bit more asphalt to push that beyond just meeting the bare minimum. And again, all mixes pass rutting. The other thing that we want to look at this is not just where if it falls in the middle of the balanced design, but what's the range? Because the range in asphalt content is very important between the minimum and the maximum during balanced design. Is that something that's achievable, or is that range so narrow that it falls out of what we would expect, again, from the precision and bias? And you can see here the balanced mix design range for a majority of them are pretty good. Mix number 8 has a range of 0.5. That's rather tight, and that's a tight tolerance to make. And even mix number 3 at 0.9. What we do believe is happening is as this range increases, we believe that the gradation and the design itself is rather robust, meaning that the gradation that's been selected provides volumetrics that provide enough asphalt into the material where you have a good durability, but yet the aggregate structure and the addition of the binder stiffness provide a good rutting resistance for the material. So not only do we want to see whether or not it is balanced, but that balanced mix design range between the minimum and the maximum is very important for us, not just from a production standpoint, but gives us confidence that that is a robust mix. This is something that we're starting to look at a little bit more. Are there minimum ranges that we want to see in this balanced mix design between the minimum and maximum that can provide additional information regarding the overall performance of the material? So in summary, real quick, again, the idea here for New York State, they wanted to take a look at their current mixes, see from a balanced mix design standpoint where they fell into play regarding their volumetric asphalt content versus performance. And this was a big jump for them in including performance testing into their possible designs in the future. As I mentioned earlier, 5 of the mixes passed the balanced mix design, 6 of them failed. Again, I think this is what would be expected. I certainly wouldn't have expected all the mixes to have failed, but I wouldn't have expected all the mixes to have passed as well. As we know, there are some general issues with typical volumetric design where we just don't see things on how it influences the performance of the mix the way that we would like. All the mixes met rutting. And again, if we go ahead and look at what we see from the field in New York State, they do have some cracking issues. They're currently not dealing with any rutting issues. So this does, again, from just a 100-foot view, it does seem to mirror what we're seeing in the field. The range, like I said before, is just as important to me as whether or not the volumetric criteria is there or not, because that range just gives us an idea of how robust that mix design is and how robust the performance of that material will be. I believe that range, as we start developing a little bit more confidence in this and we start getting an idea of how this directly compares to the field results, I think that balance mix design range will come into play in the future. And again, there's still a lot of concern regarding some of the data, okay? And again, moving forward and how we're gonna go ahead and implement this from the state perspective, you know, there's a lot of questions such as, you know, now that we have this range, where are we gonna go ahead and select asphalt content? Is it the minimum plus production tolerance? Do we find the middle of the range? You know, finding the middle of the range, is that gonna cause some production issues? So there's gotta be some practical work that move along there. As I mentioned earlier, we included a very short amount of aging for the fatigue cracking side to try to make it, the mixes being produced within a day. The idea here is, can we continue to do this? We don't want to extend the mix design process any longer than it has to, then it just doesn't become practical. So can we include some level of aging? I think what we did here is a good first start. And then quality control testing. Is a state agency going to include that? I think using those IDT tests is a great step. I think it certainly is a good way of moving forward, but there might be a couple tests that come along in the future that are just as good. But I believe a state agency not only should take a look at some of these balance mix designs from design, but once you have the design, now moving forward into QC, because that's just as or even more important at times. And then the last thing is that as we start moving in this, I want to try to remind state agencies and industry that there's going to have to be an increase in education in the regions regarding, or for the industry, regarding proper testing analysis procedures. Some of these things are fairly new, and so proper education regarding how to conduct these tests, how to conduct the analysis, what are typical errors and things to look for is going to be very important moving into the future. I want to thank PAPA for their time. Again, I apologize we could not all be here in person, but please, if you have any questions, please feel free to, if you don't have time with in the chat or anything, please feel free to email me. My cell phone is there as well, and I'd be happy to try to answer any questions now. And if anybody has anything outside, please reach out. Thank you very much.
Thank you, Tom. Appreciate the excellent presentation, and I hope that the PennDOT folks that are online watching this will grasp some of these techniques and implement them here in Pennsylvania. We have a host of questions here, and we're not going to have time to answer them all. So what we're going to do, the ones that we don't get to, we're going to get them to you, Tom, and then you can get back to the individuals that asked the question. But the first question, and this is from our good friend Greg Harder of the Asphalt Institute, and Greg asked, for the ideal CT specimens, did you age them for 4 hours at 135 degrees C first and then 2 hours at the compaction temperature? And if not, how did you get them back up to the compaction temperature?
Yeah, so what we did there is it was 2 hours. 2 hours volumetrically was always done first. Then the specimens were brought into a second oven for 4 hours at 135. And once those 4 hours were done, they were removed, put back into the compaction temperature oven, and which really only took maybe about 20 minutes to get back up to compaction temperature, and then they were compacted. So we used, and again, this is where some of this, again, this education takes place. There is going to be some modifications if this is done at a plant or in a laboratory where you're going to need multiple ovens to try to accomplish some of this in a fairly quick time. So they were all 2 hour conditioned first, Greg. Then we went to the 4 hours at 135, and then once that was completed, we quickly put them back in the first oven for about 20 minutes, about 20 to 30 minutes at the most to get it back up to compaction temperature, and then we compacted them.
Okay, Tom, this next question came from Tom Abbey, and we all know Tom. Do you believe that balanced mix design testing should occur for each mixture, that is the different end mass sizes and at each gyration level, or can we do some umbrella testing, if you will, to reduce the amount of testing of the performance?
That's a great question, Tom. I think that we need to prioritize where we do this sort of implementation. I would say lower volume roads, that have shown relatively good performance over time. you probably don't necessarily need to do something like this. I would say more heavily traveled roads, your interstates, or even some of your critical infrastructure that is complicated, like composite pavements, paving over concrete. I think the balanced mix design is best served. I certainly think you can approach it from a hierarchy perspective where you have your more critical infrastructure. Those are the ones that you target first, and then you can kind of move down the list. I don't necessarily believe that it has to be done on every particular mix, but I think, again, we have to take a look at it and see which ones are our critical structures, which are the ones that we certainly need the performance on. Not that we don't need performance on any of them, but obviously, you know, we can prioritize certain roadways over others based on traffic levels and just critical mass going out. But I do believe, you know, sitting down with the state agency and trying to prioritize where these things could be is probably your best bet to move implementation forward. I certainly don't think you would have to worry about, you know, a base course in some very low volume road somewhere that has shown minimal distress over years. I don't think it would have to be necessarily implemented for that.
Okay, thanks, Tom. And one final question, and we had several questions in this regard that were phrased a little bit differently, but the 11 mixes, approved mixes that you tested, of those 11, you said 6 of them failed the criteria. 2 of those 6 were relatively close. Do we have any information on how they're performing in the field, tying the laboratory prediction to actual field performance?
Well, that's sort of where we're trying to head with New York State right now, is to actually go back now and see where some of these mixes were placed. Again, you know, as we all know, there is a difference between laboratory produced and plant produced. And so that's going to be the one sort of caveat there, because we're not physically testing the exact material that went down. But I think, yes, that's the next logical step with New York State, is going to see where these particular mixes had been used and seeing what the general performance is. I would like to, and it all depends on whether New York State wants to do this or not, I would prefer to also go and try to core some of those locations as well and see how close the results are that we were able to achieve, especially these pavements are relatively young, and then go ahead and compare those field results to the lab produced. But yes, absolutely. And this is sort of, you know, a closed circle, Gary. You know, you come up with your criteria, you start to verify it, and then you keep verifying it, because as we know, materials are changing, production practices are changing. So it's never something that once we have a value that it just stops right there, or we have a design and it stops. It's something that we're going to have to continue evaluating and sort of, you know, continuous work on this, because I really feel that moving forward, it's just not going to be a one stop and then we're done. You know, there's always going to have to be a chance to reevaluate the specifications, see if the criteria has to change, because as we all know, everything is changing around us.
Excellent answer, Tom. And we're looking here in Pennsylvania at taking some of those longer term pavements that are performing well or some that are not performing so well, taking cores and working backwards from the back end, and how these mixes look from a performance standpoint, running and cracking from the cores of long-term pavements.
And I think that's the great way to do it. The other thing I would like to also try to push is, you know, a lot of times the state agencies, these different groups within the agency are fragmented. You know, we have to understand that, you know, the mixed design group, the materials group, the payment management group all need to have conversations with one another, because all of their information feeds off of what they're doing. So if we don't have good communication and data sharing among those groups, this is going to be even harder to implement.
Another excellent comment. Thank you very much. We appreciate your presentation this morning.
Thanks, Gary.
Okay.
Hey, Buzz.
So now we're going to move ahead here to the next presentation. I see Buzz has his presentation up there. As you heard during Jim Winford's presentation on Tuesday, the National Center for Asphalt Technology, or NCAT, is the premier asphalt pavement research agency in the world. And Charlie and I were fortunate enough a few years ago when they had the previous cycle report to have the opportunity to go down to the track, look at their facility down there, and hear firsthand the results of that previous cycle at the track. And I really sincerely hope that many of you have an opportunity here in the future to get down to that facility and see how impressive it is. So we're going to have Buzz Powell, Dr. Raymond Powell, if you will, do a highlight of the findings of the most recent 2.5-year loading cycle at the test track. Buzz earned a PhD degree in civil engineering at Auburn University with an emphasis in pavements and geomaterials. He worked for 12 years with the Alabama DOT and 2 years in the private sector before becoming NCAT's first test track manager in 1999. Buzz now is an NCAT Associate Director and an Auburn University professor. So Buzz, I'm looking forward to your presentation here this morning.
Good morning, Gary and Charlie and everybody that's participating in the meeting. Can y'all hear me okay? And see my slides?
Yes.
Excellent. Well, I'm very happy to be with y'all this morning to give you an overview of where we are with the current research cycle, which we built in 2018. So we'll call that the 2018 research cycle. And then where we are with our planning process for the next track that we'll build this summer. And then when you hear us talk about it, that'll be called the 2021 track. I love to be on the program with Dr. Bennett because he and I are very much on the same page with a lot of the things that we learn and the philosophies that we have about balanced mix design and about the future of quality pavements in the United States. And I think you'll see as I go through my presentation that is the case. I'm very happy to be with you this morning. Probably most of y'all have heard me talk about the NCAT pavement test track in the past, but I wanted to just start out with a reiteration of our mission. And what we do here is help primarily state DOTs make positive changes in their specifications. You know, as Gary mentioned, my history, I kind of grew up as an engineer in Alabama DOT. I understand the challenges that you have in the industry and the desire to make the right changes in the program. So that's what we do here. That's a big thing we do, is help industry or help agencies to make those changes. And at the same time we do that, we really get excited about doing innovative stuff. Like the NCAT mission is to do innovative, relevant, and implementable research. And it's the innovation part that we really get excited about here at the track. So and our mission statement really is safe and sustainable asphalt pavements at the lowest possible life cycle cost. We do research in 3 different areas. We do research in mix and materials. You know, what are the ideal materials to put in various layers in the pavement structure? And then when you optimize that, how thick does the pavement need to be, structural pavement design? And then if you get those things right, then what's the best way, the most cost-effective way to preserve the pavement structure and achieve the lowest possible life cycle cost? So that kind of is our mission in a nutshell. This has really resonated with state DOTs across the country. Currently, we have 34 state DOTs that participate in our partnership, our nationwide pavement research partnership with Minnesota and the test track. And then, of course, FHWA also participates in that. And then we have industry partners that also directly fund research in full partnership with all the state DOTs that do work here at the NCAT pavement test track. And we're really proud to have this research relationship with the Pennsylvania DOT. So what we do here is accelerated pavement damage. So there, you know, in the last presentation, there were questions about correlating the lab results, the balanced mix design results, to field performance. Well, we do a lot of that type of work in the lab here at NCAT in our main testing facility that's located over near campus at Auburn University. And you can kind of see the track is our big outdoor validation of the work that we do in our laboratory. It's a giant outdoor laboratory where we run. We have high-speed load events that are intended to be an interstate simulation. all of our axles on our triple trailer trains are loaded up to, but not beyond the federal legal bridge limit. So we're doing what's called accelerated pavement testing, APT, but we're not doing it by overloading our axles, because when you overload axles to fail pavements quickly, you create all kinds of confounding issues with the research. You know, how does that really relate to legal axle loads? So every axle is legal, and that gives us a gross vehicle weight that's about twice the legal limit. If you look at this 8-axle triple trailer train, that's okay because we don't have any bridge spans to collapse. It's all road here at the NCAP pavement test track on our 1.7 mile oval. So we run 5 of those trucks at a time, 2 shifts a day. So we have a staff of 10 drivers. Some of those are full-time employees and some of them part-time employees. But we run trucks on the track from about 5 in the morning until about 11 o'clock at night. And in doing this, we do about 100,000 easels a week here at the NCAP pavement test track in an interstate type of a simulation. All right, so as I said, this is accelerated pavement damage. So what is the damage that we're documenting on the track on a weekly basis? Well, we focus a lot on rutting, on roughness, and on macro texture, because rutting for us, we don't have a lot of base and subgrade rutting. Most of the rutting that we have is mixed rutting. On the roughness side, we see flat numbers in our roughness until test sections are in some stage of structural failure. And then macro texture for us, changing macro texture or raveling of the mix is a good indication of the durability of the mix. So we talk a lot in balanced mix design about rutting and cracking, but durability really tends to be very closely related to cracking, and macro texture or raveling is an important part of that for us. So we also do fall and weight deflectometer testing, noise, reflectivity, permeability, and then wet ribbed friction testing with a full scale trailer like most of the DOTs use is an important safety component of the work that we do here at the NCAP pavement test track. And then of course cracking. Dr. Bennett focused a lot on cracking performance of mixes. Well, we do research with top-down cracking primarily. Those are on perpetual pavements. Reflective cracking, and that'd be mill and inlay when we have distresses that we don't completely remove, or we have bottom-up cracking and we're just trying to get by with some type of a mill and inlay. And then we have the traditional bottom-up fatigue cracking. That happens when you have high strains at the bottom of the pavement. Pavement might not be quite as thick as it needs to be to prevent that crack from initiating in the bottom, and then of course it works its way up to the top. This is what some of our crack data looks like, and the red is data from the research cycle that this was pulled from, and then blue is cracking that was mapped in a previous research cycle. So this happens to be a perpetual pavement for a state DOT that participates here on the track. We did a mill and inlay with a mix, and then the red cracking is additional top-down cracking that occurred, and some of it, as you can see, is also reflective cracking. So in our 200-foot test sections, the middle 150 feet is the focus of most of our research, and we do detailed crack mapping, but we focus a lot on the percentage of the total lane area cracked, and then the percentage of each of the wheel paths that are cracked. We take that data and then we look at how it's changing as a function of time and traffic. So one 3-year research cycle for us here at the track is 10 million equivalent single axle loadings. That's about 6 million heavy axle passes. So this is an experiment that I'm showing you data from a previous research cycle. And I love sharing this data because it goes over 20 million easels. So it's 2 full research cycles. So this is an example of test sections that stayed in place for 2 research cycles. And we did that because at the end of 10 million easels, at the end of that first cycle, we didn't have any cracking in these sections yet. These were 6-inch pavements on a good base and a good subgrade. But as you can see, we got very aggressive cracking that occurred in the second research cycle, in that second 10 million easels. And so, a couple of things to point out about this. It's important to note when cracking starts, but the rate of cracking as it develops on these test sections as a function of time and traffic is also important. So when it starts, and then how rapidly it develops, and those are the things then that we need to relate back to the crack performance testing in the B&D process that Tom talked about in his previous presentation. So the lens that we look at this data through, we like to use the MAP 21 criteria, and we use that for on-track test sections and then off-track test sections that I'll talk about here in just a minute. MAP 21, quote, good is not to exceed 5% cracking, and this is it's a wheel path focused crack parameter, but it's both wheel paths together. So that's how we're looking at this data. And then we've got MAP 21 fair is 5 to 20% of the total lane area cracked, and then poor is more than 20%. So it's really neat to look at this data, and you can see that there was a lot of debate about what these ranges would be when the MAP 21, and these are the FHWA pavement management or asset management criteria that were developed. But if you look at how cracking rates change on the track, that 0 to 5 and 5 to 20 and more than 20 really makes a whole lot of sense, because up to 5% you generally see kind of the flat slopes, and then there's a turning point when it starts to ramp up when you get up into fair and poor. The reason why I've got that block missing in the shading on the side is because in this particular study, where we had fair and above cracking, we did preservation on those sections, and then we didn't do any preservation on the MAP 21 good test sections there in the bottom. So that's is kind of a classic example of the type of research that we do on the track, how it sometimes straddles research cycles, and then the preservation component of this actually went into an additional research cycle, 30 million easels on these 6-inch pavement structures. So the current research cycle, give you guys an update on where we are in this cycle. Well, we've got a partnership with the Minnesota Road Research Project on mixed performance testing, which is important to balance mix design, and then also pavement preservation. And this is a big reason why Pennsylvania got involved in the partnership, became a member of the partnership, because of the cold weather focus in Minnesota, and then the hot weather focus down in Alabama here at Auburn. So on the mixed performance side, our emphasis is which tests predict top-down cracking at the NCAT track, and then thermal cracking at the Minnesota, the mainline bypass at the Minroad test facility. So we need to know this, because how can we improve balanced mix design outcomes? Where do those threshold values need to be? Tom talked a lot about where we needed to be in cracking performance and where we need to be in rutting performance. And those numbers are very dependent on the liquid asphalt that you're using in the area of the country that you're operating in, and you're going to see some differences in the numbers that we track that I'm going to share with you here in just a little bit. Mix design approval versus construction quality testing. And I have a lot of fun here at the track because of the perspective that I have. I wrote and enforced specifications when I was assistant testing engineer for Alabama DOT, and so I think I have I'm good at wearing the agency cap. But also for construction quality testing, we actually are our own prime contractors here at the NCAT track when we rebuild test sections every 3 years. And so I think I have a good perspective on what is reasonable in construction quality testing, and what kind of specifications can we implement that can be achievable if you're a contractor that's working with those specifications. So what are another big focus area in this research cycle is what are the short-term versus the long-term benefits of recycling agents. We use, otherwise known as rejuvenators, we use recycling agents because we want to wake up and rejuvenate the aged asphalt binder in the wrap that we need to use as much as possible of to be the sustainable industry that we all know that we are. Well, especially as we get into multi-generational wrap, Tom made the comment, not all wrap is the same. Well, you can take roads that are milled over multiple mill cycles and multiple life cycles of surface mixes, and the mix may otherwise be identical, but as you go through multiple age cycles, the wrap is changing. So this is why, as we look at balanced mix design and we strive to hit performance targets, cracking performance targets in particular for our mixes, then we're going to need to have tools in the toolbox that are recycling agents that don't just soften the mix at the time that we produced it, but show that it has sustainable benefits when we do critical aging on those mixes. And that's the kind of longer term testing that we need to do to approve our mix designs if we're the agency. So we need quick testing for jobs that are being produced, as Tom said, but we need some more rigorous, some critical age testing when we approve our mix designs, so that we can show the sustained benefit in particular of these recycling agents. And we can use this then to assess the quality of not just our reclaimed and recycled materials, but also our virgin materials. And then another big focus area for us on the track, and this is something that we've grown in since the first research cycle back in 2000, we do more and more evaluation of local aggregates. So we want to be a sustainable industry. We have to be a sustainable industry. So rather than using index tests to assess quarries and say, well, this quarry is okay for surface mixes and this quarry is not okay for surface mixes, a big focus of our research here is, and I kind of see it as an extension of balanced mix design. If you got a mix that's not going to rut and not going to crack, well, is it going to get slick on a roadway, or is it going to have sustained friction values? We have tools in the laboratory now that we can use to assess mixes for sustained friction or terminal friction values. And I maintained the aggregate control program when I was with Alabama DOT, and I'm an advocate of not just saying we can't use this source in a surface mix, or we have to limit it to this percentage in a surface mix. Let's look at the total friction of the surface mix, and then allow industry to innovate, to blend stockpiles together to hit whatever friction target the agency thinks it needs to establish for safe roadways. So I'm going to touch on some of these areas as I go through the rest of my presentation for giving you an update in the current research cycle. And this top-down cracking experiment that we're doing here at NCAT, we looked at, Tom talked about lab-produced mixes versus field-produced mixes. So we have the advantage here at the track of kind of doing all that at the same time in our research program and the research cooperative that Pennsylvania participates in. So we've got lab compacted specimens with plant aging, and then with that critical aging to take it out to 5 years to see what the age binder properties are. Then we've got plant sample material that we test, and then plant sample material that we do that critical aging to. So we've got 4 data sets that we work with, and it's been really interesting over the course of this study that I'm sharing with you now, this CG experiment, multi-state experiment, to see how all those numbers relate to each other. So the tests that you see on this slide are the consensus tests that the funding state partners decided they wanted to include in this experiment. In the southern half of the experiment, we have other stuff that we're doing on the northern half of the experiment, where DCT type testing to determine if we're going to have a thermal cracking problem. This is the top-down fatigue cracking part of the test. So these are correlations that we're seeing comparing the lab data to track data, to severity of cracking in a group of test sections that are included in this cracking group experiment. And these test sections were built with an intentionally broad range of cracking performance. These are thin pavement structures where we use highly polymer modified binder in the lower layers, in the non-surface layers, so that we can have a lot of some good deflections in these structures, so that we can excite the surface mixes. But all the cracking that we're seeing on the track, and we verified this with forensics, is in the surface layers. So then we're doing crack testing in the surface layers, and then this shows you how the surface layer cracking compares to the laboratory index tests that we ran. And you see a lot of tests that Tom talked about in his presentation. Now, for mixed design approval, as I said, putting on my agency hat, we need to approve mixed designs using critical agent, because you might want to use a recycling agent that is not shown to have sustained value out 5 years in the future, when you're going to have a critical cracking time for the performance of that mix. So we need to simulate that in the lab and use that number to approve our mix designs. And you see some really good correlations. There are a lot of tests. The only one that did not correlate well is the energy ratio test. But you got a lot of options to do that critically aged mix design approval, and you got time to work with when you go through that approval process, because it's not that rapid fire construction quality testing that we really need to do as quickly as possible. On the rapid testing side of the process, that's just reheated material or plant aged material or simulated that plant aging material in some of the other data that we have. And you don't have quite as many options there in terms of the values of the correlations. And I narrow this down. I'm a big proponent of ideal CT testing. And as Tom said, the numbers all tend to relate to each other. You see a good, the ideal CT coefficient of determination is about equal to IFIT. So they both have value there, but ideal CT testing, since you don't have to saw or do any kind of special preparation, that is the test that I'm a big advocate of, because we've proven this through the testing that we do at the track. You can turn those numbers around within a 4-hour window. So that means if you're a contractor and you start running mix early in the morning, you've already had the opportunity to make a correction to production before lunch, so that you can make sure that you stay in spec or stay in bonus or working within whatever type of specification it is that you're working within in your particular agency and your particular philosophy. So you got a lot of options for critical aging for mix design approval, but for QC, and I think Tom is in agreement with me, the ideal CT is the way to go. And with that testing, it's like TSR samples. If you're accustomed to producing TSR specimens, you can pull material right out of the back of the truck, put it, as long as it's hot and compactable, you put it right in the gyratory compactor. You're compacting to height, not to end design. So you don't have to get it up to design compaction temperature. So you can take it right out of the truck, put it in the gyratory. You can rapidly process that in the lab. And as I said, within 3 to 4 hours, you can have a number for a mix so that you know if you're in spec or not. So I wanted to talk a little bit about aging, about this critical aging process. So this is loose lab mix or plant mix is spread out evenly in a pan. The specification that is currently out there says, well, to simulate the plant, you need to age for 4 hours loose mix at 275 degrees Fahrenheit. Most of what I'm hearing from the field and most of what I've seen in the mixes that we work with, the number to actually simulate what's happening in the plant is probably more like 2 hours. So 4 hours is going to give you a more rigorous requirement. But if you're trying to simulate in the lab what you're going to see in the plant, then we probably need to revisit that and cut that back to more like 2 hours. This critical aging that I'm talking about is, for us, is about 8 more hours at 275F loose mix, 8 additional hours on top of the plant simulation aging. So the actual length of the oven time for us is based on the concept of cumulative degree days. So you may need to adjust that based on your location and your climate. So that primarily is driven by latitude and by solar radiation and oxidation. So as you go north, that critical aging time would go down based on that. And as I said, we need critical aging to assess the sustainability of recycling agents, for example. We don't need that for construction. So you need to approve mixes with a different pass bar than you do for production mixes, because we're not going to critically age that production mix, because it takes too much time when you throw 8 additional hours of aging into that process. So hopefully that makes sense for everybody. So how do these numbers relate to each other? Just the plant aging versus plant age and critical aging. Well, at the NCAT track, you get, as you can see from the change in these ideal CT numbers, when you go through critical aging, it ends up being about a third of what you see when you're just heating the reheated, just testing the reheated values. And that is at the NCAT track. At Minroad, with their binders and their climate, the cold climate up there, it's about 45%. The reheat value is about 45%, or excuse me, the critical age value is about 45% of the reheat only value. Now, look at the scale on this plot, and this is important. I want to kind of contrast this with the numbers that Tom or Dr. Bennett was talking about in his presentation. He was talking about ideal CT numbers that are over 100. This is this is Minnesota mixes, Minnesota binders, for their climate, which is extremely rigorous. We've had air temperatures on these test sections down to minus 45 degrees Fahrenheit in the dead of a really harsh winter there. And our ideal CT numbers are, we only had one with just reheating that was over 100, and then with critical aging that dropped down to a 40 because of this kind of relationship reduction from critical aging. So kind of keep that in mind. And what I personally advocate is what Tom suggested: do some testing, do some baseline testing with the mixes that you have. Look at mixes that you're pleased with performance with in the field, and then use that to establish what your threshold criteria are. This is also very, very sensitive to the binders. So you can actually take polymer modified binder versus neat binder, and you can see some significant reductions in ideal CT values when you go from neat asphalt to polymer modified asphalt. So you really got to do some research in your particular market, but the framework for the process is really what we're focused on here. For one of our southern states that participates in our partnership, we did a big field project for them at NCAT where we sampled mix that was being produced at the plant, and then we tested it for ideal CT with reheated value versus the critically aged value. And for this particular agency, with their binder market and their aggregate structures in their mixes, it was about 57%. And the reason why I'm pointing out these numbers, estimating the drop that you get with critical aging is really important, because if you're a contractor and you're developing mix designs and you're trying to anticipate, well, when I submit this design for approval, what is the agency going to test? You can rapidly go through your mix designs, make some assumptions about critical aging reductions, and then when you get to your final design, just do a validation with that 8 hours of aging. So there's ways, if you're a contractor, where you can speed up your mix design process if there is a BMD requirement and it involves these types of tests. Now, all the data that I showed you, none of it includes recycling agents, so that the rules of thumb for reductions when you do the critical aging, when you put the recycling agents in there, again, I pointed out some of those are sustained and some of them are not sustained, and you need to do some work with your mix design so that you know what kind of a reduction you're going to get with critical aging, because that's how I advocate we approve our mix designs. So I've talked you saw a lot of ideal CT numbers on those previous slides. They're a lot lower than the ideal CT numbers that Dr. Bennett talked about in the study that he's done for New York DOT. And I want to show you where our numbers come from and how they relate to cracking performance on the track. So that the array of numbers at the bottom of this plot, those are ideal CT numbers for reheated plant mix, with reheating and critical aging, and then the bottom two lines there are mix design data. That's lab mix, lab compacted, with plant aging, short-term oven aged, and then with the additional critical aging. So you see how you're dropping when you go from just the plant heating, plant aging to critical aging. All those numbers are changing in there. So these are the 7 test sections that were included in our cracking group study here at the NCAT pavement test track. These 2 sections started cracking first and cracked very aggressively. So look at those ideal CT numbers underneath those 2 test sections. These 2 sections started cracking next, but the development of the cracking has been much less aggressive. A clear distinction in cracking performance on the track was with the 3 sections on the right side of this plot, sections S5, S6, and S13. That means they're on the south tangent of the track, sequential numbers 5, 6, and then on down at the east end, section number 13. So what these are showing us is if you're doing work in the mix design laboratory, if you get a 40 or better with plant aging, with that 4-hour plant aging, then we saw good performance on the track, and then that dropped to an 11 with critical aging in the case of that test section. When that mix was produced, if it's a 30 or better with reheating, and that's what you'd be doing with QC testing, for example, if you're testing that mix, we saw a clear distinction and a clear improvement in cracking performance, or kind of a break point. And then with critical aging, that dropped to a 16. And then section S13, that is an Arizona rubber surface mix with extremely good cracking performance. So the QC test was a 250, ideal CT of 250 on average. But when you do that 8 hours of critical aging very aggressively attacks rubber modified asphalts. So that's one area that we really got to focus on comparing to good field performance. That dropped to a 68. So that's important information to know. So that kind of 40 value is, if I'm writing an agency specification, that's a really important number for me to be thinking about. And that's in the southeastern United States with kind of the binder grades that we use in the southeastern United States. That's very different than that plus 100 number that Dr. Bennett talked about in his presentation. So what are some possible CT index criteria if you're writing a specification? Well, based on what I shared with you on that previous plot and data that we've collected on other mixes that we've run, and I would propose that you are designing a mix without critical aging at a 50 or better as a minimum. And again, 40 kind of was a break point for us. If you've got kind of a medium traffic roadway and you need some enhanced performance, maybe that number is a 75, and then that you can kind of come down off of that and establish critically aged from the plant, and then mix design with critical aging. And then maybe if it's a really high traffic roadway, very robust traffic conditions, maybe it's a 100 or better, and then reductions when you apply the critical aging to that. And this is not written in stone. This is just kind of as an example of how your agency might want to consider writing a CT index specification. Anytime we produce mix on the track, this is actually a picture from our lab. I learned this from Dr. Bennett at a previous, I think it was at a previous annual meeting with the association in Pennsylvania. So we do our ideal CT testing at 77F in that left water bath. We also do hot IDT testing in that right water bath. We do them both in the same screw press. And you know, there's some issues with relating a screw press to a servo hydraulic machine, but we're not seeing statistically significant differences between the two. So this machine would not be compliant. You know, an agency approving mix designs, you need to use an ASTM compliant machine, but we also need to utilize the resources we have in the field for mix design and for QC testing, and we see good relationships between those. So that kind of possible spec approach that I showed you is based on our CG data, but it's also based on just looking at our data that we produce when we do our 4-hour QC testing whenever we build test sections on the track. So just a summary of BMD concerns. These are things that we need to be thinking about when we want to implement balanced mix design. We've done round robins. We need to do more round robins with the exact same mix to discover how results compare between labs and between technicians. You know, we need regional data to prove how the ASTM compliant servo hydraulic machines compare to the old screw drive machines, so that we know how to develop designs and then how to enforce our specifications. What are the right BMD threshold requirements for your market, for your aggregates, your blends, and your binders? How do the numbers change as you get different binder loads of asphalt binder in? What happens to your BMD numbers? But there are some cases in some markets where there can be some fluctuations in ideal CT values where nothing changes with the aggregates. It's all about the binders. Mix design results versus unaged construction results for your mixes. How do those compare? How do we need to integrate this into some kind of a pay adjustment system where you maybe percent within limits? Do we just need to have a minimum value and then look at volumetrics for pay adjustment to reward for consistency? You know, those are implementation concerns that we need to have. And then we need to know a lot about recycling agents. There are a lot of products out there now. The majority of them are green focused products, and we need to know, are they just softeners that are going to play out in the early age of that mix on the roadway, or are they true rejuvenators, and they're going to have sustained value out there and provide that good cracking performance out there at year 5, which is what the agencies really need. We also have ongoing pavement preservation research, and this is something that all the agencies that are in the Min-Road Partnership are very concerned about this. We have test sections, low traffic and high traffic down here, low traffic and high traffic up in Minnesota. This is data. This is actually a picture of our low traffic roadway. It's the dead end access road to a quarry and an asphalt plant, and you can see the individual 100-foot dual lane test sections that we have out there. We split the performance down between MAP 21 pretreatment, good, fair, and poor, like I showed you guys earlier. And then the bump that you get from pavement preservation, this is for single layer microsurfacing, is the gap between the solid lines and the dash lines. You can download this data from pavetrack.com. If you go to click the pavement preservation link, and you can see performance data for all of our test roads, for Lee Road 159, 280, and then you can also see data from the Min-Road test section. So that shaded area is the improvement from preservation that you get from pretreatment fair in accordance with MAP 21. You also see in this data, and again, this is single layer microsurface, that the performance is similar all the way up to pretreatment poor. So you see a big drop in performance when you go to 20% or above cracking, and this is consistent with the guidelines that you see in a lot of the pavement preservation criteria. It's not recommended to use single layer microsurfacing when you have extensive cracking on a roadway, because the cracking is going to reflect pretty rapidly, and that's what we see in our data there. Of course, I'm not going to focus on, we don't compare treatments. This is data just for preservation thin lays. I like to show this data because the top sections are Minnesota, low volume on the left, high volume on the right. This picture is after 5 years of traffic, and on the bottom, low volume on the left, high volume on the right. After 9 years and 6 years respectively, we're seeing excellent performance from the thin lays. We're seeing excellent performance from many of the emulsion treatments, and again, you can kind of get into this data if you go to our pavetrack.com website. So that's preservation. Well, what about when we're not preserving pavements, when we're band-aiding pavements? And this is a study we're doing where if you've got full depth cracking and all you can do is a mill and inlay, what can you do to prevent reflective cracking? So the two nearest test sections that you see, those are hot mix options. The one that's the farthest away is Arizona Rubber Mix as an interlayer, as a reflective crack reducing interlayer. The one that's nearest you is an open graded interlayer, a lot like an OGSC without the fibers and the polymers. And on the other end of this test bed, you see chip seals in the middle, one with virgin aggregate and one with coarse fractionated wrap aggregate. And then you've got geosynthetics on the far end. You got a grid on the right and just a fabric on the left. And then we're looking at how much reflective cracking are we getting from these test sections. Well, what if a pavement is in complete failure out there and you're struggling with how can I rebuild this roadway in the quickest way possible, in the most cost-effective way possible? This is a full depth rapid rebuild test section where we did 8 inches in a single pass. You see that some of the strain gauges, and there also are some pressure plates there, so we can measure high-speed pavement response. This test section turned out extremely well. It's a surface mix at a depth of 8 inches in a single pass. We cut cores to do multi-depth, the density profiles. Density was outstanding. We did this with using a warm mix additive at the time that we placed it. And the only issue with this, which we knew was going to be challenging, was roughness. So we did come back and do diamond grinding, and we got this less than 100 inches per mile with diamond grinding. And now this practice has been implemented by South Carolina. This is their test section, and their contractors are working with how can we hit a better smoothness target without diamond grinding. And my understanding is they're getting down in the 60 inch per mile range with this as they get better with it, and they learn how to line their trucks up so that they can more consistently feed mix to their paver in these full depth rebuilds. Well, your other option when you have full depth failure is to do something like 100% recycling, like a full depth reclamation. So this is a test road up in Minnesota at 70th Street. It's the access road to Min Road, and as you can see, it's 4.5 inches thick in a wet soil location with a hard freeze and a lot of moisture. Been a lot of maintenance that's been done on this roadway. Well, we came in on this road and did things like cold in place recycling, cold central plant recycling, full depth reclamation. We also did 2-inch versus 3-inch mill and inlay, and then 1/10 of a mile test sections. Then on this roadway, we came back and put 1-inch thin overlays on them. So these are 100% recycling sections that compare to our recycle sections that we built on US 280 back in 2015. And now we finally have recycling sections up in Minnesota built in the summer of 2019, and performance has been outstanding on these test sections so far. So that brings us up to where we are with our next research cycle, and we're deep in the planning process for this. We are going to have an extension of the Min Road partnership where we look at mixed performance, and we continue to look at pavement preservation. We're not looking at BMD tests in this cycle. We're looking at what is the benefit of, quote, premium mix additives on pavement life, and we're calling this an additive group experiment. So the outcome of this study, the deliverable, is going to be layer coefficients for premium mix additive modified mixes, or calibrated ME models, the layer coefficients for or calibrated ME models for pavements that are doing mechanistic, or states doing mechanistic designs, or layer coefficients that are still doing the 93 AASHTO design guide. Sorry, I got tongue tied there. So we're kind of in the middle of our phase 1 design testing and modeling that we're doing, where we have the additive manufacturers and suppliers are funding their own phase 1 experiments here at NCAT. We're going to be working with the sponsors of the AG study to decide which ones get included at NCAT, which ones get included up at Min Road. We're going to be building Min Road sections, it looks like right now, in the summer of 2022. We typically build test sections up there with a 1-year offset from NCAT so that we can mobilize our resources and support construction in both locations. And we also are going to be looking at a lot of the standalone stuff that we do in every research cycle. For example, friction research. How can we maintain as much aggregate source availability as possible and provide safe roadways? TAC and layer bonding is going to be another emphasis area for us from our state sponsors, and then doing more work with cold recycle pavement thickness design. How much hot mix do you need to put on top of cold recycle base layers? Because we think cold recycle base layers are going to be becoming more common. We can study anything in mixing materials, structural pavement design, and preservation on the track that a state wants to study, but those are the kind of the high points, and there are a lot of other individual studies that we'll be looking at as well. So this AG study that I talked about, the additive group experiment, there's a long name for it, but it's really all about quantifying the effect on pavement life that you get when you add stuff to hot mix asphalt. The stuff that we're going to add are things like aramid fibers, plastics, epoxies, rubbers, anything else that a vendor comes up and is trying to encourage a state DOT to specify or to utilize to what, they claim that they can make pavement last longer or build the pavement thinner. We're going to put that to the test here in this AG study. So the first deliverable is the layer coefficient or the calibrated ME model. The next deliverable is a framework for laboratory only evaluations for future additives, so that people like Dr. Bennett, a framework that Pennsylvania could adopt, for example, that Dr. Bennett could take a new plastic product and evaluate it in the lab, have a validated model process you could go through and say, well, this is going to be the effect of this material on fatigue life based on the NCAT study, and then thermal cracking performance based on the Min Road half of the study. So to summarize here with key takeaways, NCAT is one of those organizations that really stands in the gap between industry and agencies. This is my 22nd year now, praise God for that. And we do a lot of support work directly for agencies. We do a lot of support work directly for industry. And because we don't have any kind of a bias, all we want to do is make roads last longer and provide greater value. We're counted on by both sides of the fence for ground truth for pavement performance. The test track plays a big role in that. So the track as a validating ground truth for the testing and the research that we do over at the main NCAT laboratory. We have the Minroad partnership for nationwide impact. That's really important for a state like Pennsylvania. When Pennsylvania didn't get involved in our research cooperative, when we were more of the SEC test track, because of the climate that we're in, the Minroad partnership has made it very appealing for a lot of northern states like Pennsylvania, like Wisconsin, like Michigan, that you have cold weather challenges that we don't have here in the southeastern United States, and Minroad has scoped that in for you. I'm a personal advocate for mixed design approval with plant aging, simulated plant aging plus critical aging, and that there needs to be some regional work on what your cutoff values are. We need that critical aging because of recycling agents. And we can come up with rule of thumb correlations for mix that does not contain recycling agents. As long as we got a good representative wrap sample, we have good rules of thumb. As you saw in those slides that I showed you, recycling agents are going to become more and more necessary, I believe, as we go through multi-generational wrap utilization. And so we need to account for that. We do need rapid turnaround for our construction testing, as Dr. Bennett stressed in his presentation. We know that we can do that with 3 to 4 hours of turnaround time. We prove that every time we run mix here at the track as a proof of concept. And I'm really confident that we can that I could write a specification, putting on my agency hat, that's enforceable to create that level playing field that also promotes innovation. And I'm putting on my contractor's hat. I'm also really confident that I can meet a specification like that. And I would be really excited as a contractor, because I think I could be more competitive if you relax your volumetric requirements, which don't necessarily tell you anything about mix quality, and then allow me to combine all of my materials, look at things like recycling agents, look at things like plant enhancements, that type of stuff, so that I can provide you with a better product in the most competitive way possible. And then finally, this deal with premium mix additives, plastics and rubbers and fibers. In particular, those are already huge issues for state agencies in the United States, and they're because of the focus on sustainability, kind of global sustainability. We're going to be hit with more and more products. So it's important for us to validate the products that are already out there, or assess the products that are already out there, but then also to develop this framework that can be used to evaluate future products without the need to build full-scale test sections. So we host our conference. Gary mentioned the conference when he was doing my introduction. At the end of every 3-year research cycle, we host a conference, and we push this one back. Normally we do this conference either in the winter or the spring. We've rescheduled it to June 22nd, 23rd, and 24th. And we did that based on, we made that decision a couple months ago based on the expectation for vaccines and when we think people will be able to travel. And we think this is going to be more of a hybrid conference, probably half in-person participation and half virtual participation. But we're designing an agenda that we think will provide implementation value for both types of participation. So we would encourage everybody who's in this meeting to get involved in this, because it is a great exchange of information with an implementation focus. So Charlie and Gary and everyone in attendance, that was all that I had to share with you today. And if I have time, I'll be really happy to answer any questions that you might have.
Okay, well, Buzz, thank you very much for the excellent presentation. Your presentation is always very good, and it's always very practical, because as you said, you've been on both sides, as Charlie and I both have been here in Pennsylvania. At the test track, when Tom gave his presentation, the number of questions revolved around, are we able to tie laboratory prediction to field performance? And that's exactly what you're doing down at the test track, albeit it's accelerated field performance, but still you have some good ties there. And I was particularly perked up when you made your comment. It sounds like you have a pretty high level of confidence with the using the ideal CT test procedure for cracking resistance. So, and I'm also excited about your next cycle, particularly with using premium modified mixes and determining what are the structural coefficients or structural values you get out of them for use in the pavement structural design. That's an argument we've been making to PennDOT here for a while now, and to adjust their structural designs to account for the advantages that we get from all these additives that we're putting in our mixes today. I don't believe we have any questions for you, but if anybody wants to send us any questions or get in touch with Buzz directly, please do that. Or if you send us some additional questions, and then we'll get in touch and get answers for you. So thank you again. Always a pleasure to listen to your reports.
Thank y'all so much. I appreciate the opportunity to make a contribution to your meeting. Always do.
Thank you, Buzz.
And I should have thanked Buzz also for getting this back closer to our timeline here. But let's move on to the next presentation. Dr. Mansoor Soleimani from Penn State will highlight the recommendations for maintenance treatments and cycles for Pennsylvania's long life asphalt pavement, or perpetual pavements. And we use those terms interchangeably because we're looking for a perpetual pavement performance with our long life asphalt pavement in Pennsylvania. But first, let me say that the genesis of the effort that Mansoor is going to report on really came from a request from PennDOT to recommend and support with documentation treatment cycles and treatment types for long life asphalt pavement. And this recommendation or request came to us around the end of 2019, so over a year ago. When PAPA got that request, we contracted with Mansoor to assist in this effort. And the Mansoor and Dennis Morian and myself worked together for over 3 months to prepare it's over a 50-page white paper that we presented to the department. And we had an opportunity then to present that information via a PowerPoint. The middle of are we on? The middle of September of this past year, and PennDOT's now considering the recommendations that came out of that report. So Dr. Mansoor Soleimani is a research professor with the Pennsylvania State University and a registered professional engineer in Pennsylvania and Texas. He is currently director of the Penn State Northeast Center of Excellence for Pavement Technology, that's NECEP, where he directs the center's program and supervises training and research projects in the areas of asphalt pavements and materials. Prior to this, for a period of 3 years, he acted as a director of the infrastructure program at Penn State University, where he coordinated the activities of the program, its faculty, staff, students, and resources. Mansoor has over 30 years of experience in conducting research and training in the areas of pavements and materials, and has over 150 technical publications on research projects with which he has been involved. Through his career, he has been principal investigator or co-principal investigator on projects with total funds exceeding $8 million. So Mansoor, we're working on getting you up, your PowerPoint up here.
Good morning. Can you hear me okay?
Yes, I can hear you well, Mansoor.
Can you see me?
Not yet.
Oh,
Nope. We
right.
can't
Well,
hear you. We don't see your presentation either. I don't see you. I don't see you as being a presenter currently.
boy. Let me see what I can do here, but you can't hear me. You cannot
Very
see
well.
me.
No, can't see you and we can't see your presentation.
Mansoor, I can see you. You should just need to bring up your presentation.
I'm trying to share my presentation. Here is, it says show, and I'm pushing show. No?
You had it up there for a second, Mansoor. There it is.
Okay, good.
Well, I guess I had to move it. Yeah, I had to move it to a different screen. Does it show like a presentation, or does it show like
You need to go up to the top of your screen there and display settings and click on that and make it presenter. Click on that. You got to click it. You'll get a down arrow. There you go. Swap presenter view slideshow. There you go. There you
got
go.
it. You got it.
Now you're ready to rumble. It's all,
You're okay
it's all
now?
yours. Yep, you're good. You sound good and your presentation's up. So go ahead, Mansoor.
okay? Okay, now? Hello?
Good.
We can hear you,
Okay,
Mansoor.
good.
Go ahead.
Very good. Well, good morning again. I'm sorry for inconvenience in the beginning. I'm new to this GoToWebinar. It is nice to be with you, pleasure to be with you. Papa is one of my most favorite conferences, and I can't wait to get back to see you all in Hershey next year. So Gary mentioned how this thing evolved and how we got started on this work on pulling together information on perpetual pavement and how it exists and how it performs and how long we can wait before we do any treatment to that. So what I'm going to present is nothing new. Basically, it is something that most of us at least believe in. We know these pavements do exist and perform well. What I'm going to do is basically just provide some sort of a maybe supporting evidence or documentation that these pavements do exist and perform. So to do that, I do talk a little bit about the validity of the concept and the existence of perpetual pavement, and that goes hand in hand with SMA mixes. So we do talk about SMA very briefly and the fact that they do really do better performance than conventional mixes. We talk about performance models and how they come into play in terms of designing perpetual pavements. And that also ties into performance testing and the testing that needs to be done to provide us with the input to the performance models and balanced mix design. And we touch a little bit on the endurance limit because the concept of perpetual pavement is mainly built upon the idea of limiting the strains within the pavement structure. And finally, we do a little bit of the cost analysis of this thing. So what is a perpetual pavement? Well, if you want to structure the definition, I guess it depends on who you talk to. But if you go back to some of the documents from Asphalt Pavement Alliance and NAPA, you would see that the consensus is a pavement that lasts 50 years before you need to do any major rehab to the pavement. And within that 50 years, you don't need to go in there often to do any major repair. If anything, you do some maybe surface treatment or a mill and fill at maybe a couple of intervals within that 50-year period. And in some sense, you could refer to these also as long life asphalt pavements. So the structure of modern perpetual pavements pretty much are built upon the concept of 3 layers. Now, these layers, rather than 3, could be maybe 4 or 5, but even if you extend the number of layers, in principle, they end up to be in the 3 categories that you see. You have the very top layer, which is typically a high quality polymer modified binder SMA type of mix in about 1.5 to 3 inches there. Then you have your high modulus asphalt, that rut resistant layer, because that is where you see a lot of your shear stresses developing in the pavement under heavy loaded trucks. And that is where you want to create a lot of rut resistance. Eventually, you have your bottom layer, which is about 3 inches, and we refer to that as a rich bottom because it is a little bit on the higher end of asphalt to give you flexibility and crack resistance. And your important consideration in a perpetual pavement should be that these 3 layers should be working monolithically, all together in one piece, bonded together well, so that you carry all of the strain, the tensile strain, to this very bottom, and you try to limit that so cracking from the bottom to the top does not occur. If you do have a debonding or separation of the layers, then that is going to cause you a problem, and that would not be what we refer to as a good working perpetual pavement. The other thing you want to do is to limit the level of strain at the top of your subgrade, because you already have a high modulus material here, which is hard to rut. It is very resistant to rutting, but you do have the potential of rutting at the bottom, so you need to limit your strains in your subgrade to the extent you could, and that gives you the overall structure to be rut resistant. So that is pretty much what a modern perpetual pavement definition and structure is. So the question becomes, what is the evidence that these pavements work? There is an ample amount of evidence in that respect. They come from different sources. I have some of them here for you. If you look at Asphalt Pavement Alliance award winners, and 9 of those are in Pennsylvania, they pretty much come within the definition of this perpetual pavement thing. Sharp long-term pavement performance general pavement studies, this goes back to at least now about 3 decades, and there is a lot of information on some of these long performing pavements in there. And then there are some examples from various states within the country and some international with that respect. Now, Pennsylvania has some long life performing pavements, some that have been historically performing very well, and some have been placed very recently with promise because of what we see in the performance test results. Let me talk about that a little bit. And finally, NCAT has been working on perpetual pavements for quite a long time. And I do talk a little bit about one of the research cycles of 2003, where they had these perpetual pavements along with some other sections that they were working on. So that data is really the supporting data to show that these pavements work. On the APA, the criteria is that they should be at least 35 years old with no structural failure, and you would not need to go there and do any major work. And if you add anything to the top of this, if you add any material to the top, it should not be more than 4 inches within that 35 years. And the inner wall between the times you go and do something to the pavement should not be less than 13 years. And with that, through 2019, there has been a good number of award winners, 144 to be exact. And the range of the age of these pavements when they did get into some sort of a treatment was 35 years to 99 years, with the average of 45.4 years. So that is pretty significant. Outside APA, if you look at GPS sections, you would see that especially if you go to the Northeast region, the Mid-Atlantic states, and you look at some of the wet freeze states like Pennsylvania, you would notice that the number of years it takes before you do your first treatment is actually 18 to 20 years. So that's a pretty long time to wait before you have to do any treatment to the road. So that's pretty impressive. So looking at some other examples of perpetual pavements from various states and countries, you would see that they have different ways of looking at the thickness of the layers, what they consider to be perpetual pavement. You go as low as even 11 inches in some cases, and as high as 22 or 23 inches. And that's a pretty wide range. And of course, that range depends on your material and your foundation and your traffic level and what you consider to be structurally sound. So that makes sense to have a range of thicknesses here. If you look at the criteria applied in terms of those strain levels that I mentioned, most of them require that the tensile strain to be at the bottom of your asphalt layer to be limited to 70 microstrain, and the vertical strain to 200. Now, there are cases where people are looking at a little bit lower levels of the strain, or even higher in terms of tensile strain, or vertical even to be 250 rather than 200. But for majority, you see that they are pretty much commonly the same. Now, if you look at the Pennsylvania long-performing pavements, I guess this might be a little bit a crowded table, but there are a couple of columns of this table I would like to refer to. The years before you get to the pavement to do any treatment, and the thickness of the asphalt layer. And if you look at the years, in this particular table, you don't see any number less than 15 years. That's when you go to do something, and that something is typically a milling and filling of the pavement and resurfacing. But in some cases, even not that level, maybe even minor repair that you needed to do. So if you look at the thickness, you'll get a range of 14 to 23. So you have 14-inch thick asphalt pavements that have been performing for 18 years before you needed to go and do any mill and fill of the surface. Here are some more examples. Again, you see the years being variable, but you have some as low as 15 years. And the thicknesses be in the range of 14, 14 and a half. So you can make pavements with this thickness to be perpetual and perform for an extended time before you get there to do any kind of treatment there. Finally, I mentioned some of the work that NCAT folks have done. Excellent work in terms of looking at perpetual pavement performance with years of service, many cycles of this truck loading and easels. And through their work, they noticed that some of these sections, specifically the ones that I'm having my pointer on, this is the N9, These two are N3 and N4. You may not see N3 clearly because it is almost identical to N4. It is sitting right under that. So it's hard to see, but these three that are to the left of the graph performed excellent with no cracking. There were some minor longitudinal cracks as reported in N3, and they were top-down cracking and not bottom-up cracking, but minor. The others cracked. So 3 of them did not crack to the left, and the other 3 cracked there to the right. And eventually what happened, they came up with this idea of rather than the ones that did not crack had strains exceeding those 70 microstrain levels, fatigue endurance limit levels that we talked about. And they came up with the idea that, well, we may not be able to tie this into single digit, single value as a limit for cracking. It makes sense to look at the spectrum of strains developed within the body and see how frequent they occur. For example, if you look at the 200 microstrain level, if you go vertically up, you go to this one which cracked. What this tells you is that only 45% of the strains were under 200 microstrain, and more than 45% were over 200, and so on. You could look at other points for the same reason. Now, if you continue 200 microstrain all the way, for example, to N3 and N4, it tells you over 90% of the time you could keep your strains under, so under 200. So what really is important here is not a specific number, a single number to decide that I don't want to be over that number so that it doesn't fatigue or crack. Rather, it is the accumulation of these strains and how much of that happens, what percent of that level of a strain is happening in the pavement structure. So then they develop their threshold criteria, their fatigue limits. You see the dashed line here and the solid line that was added later as an improvement. So more stringent criteria on where we would like to be. So those pavements took very heavy load for a long time and performed very well. So that proves the concept as well. So I went through a bunch of these for you to indicate the availability or validity of the concept of perpetual pavement. And it's not just on the paper, it is a proven fact. And we have had different documents or different research done on this all through field projects that we know they're working well. Now, what goes hand in hand with the perpetual pavement is a top layer to be of high quality. And typically, SMA mixes give us what we need because they do give us a very good rock-to-rock contact with high binder content, polymer modified. So that gives us the extra performance that we need out of the pavement. And again, the proof of SMA to be giving us better life is also out there, again, from NCAT work, as well as some of the work that PennDOT has done and some of the data that PennDOT has put together. And also from the first international conference on SMA 2018 in Georgia, that also provided a lot of information in that respect. You look at SMA varying course of the ones that I mentioned to you, N3, N4, and N9, those 3 sections of the 2003 cycle giving very good performance. You look at the N9, they use a 2-inch SMA. They use a 3-inch rich bottom mix there and 14 inches total. Now, surprisingly, the other 2 that, of course, developed higher strains within the body of the structure compared to N9, N3 and N4 did, but still they performed very well. And the thickness of the asphalt was not that high. And this could really happen if you have a very strong, good foundation. So this must have been placed on a very good support, subgrade, subbase to give you the ability to reduce your asphalt and be able to provide a mix that performed like a perpetual pavement, a 14-inch pavement that you see here. On the PennDOT side, on the data that I mentioned to you, showing the evidence of SMA being a prominent premium mix and giving you extra life, is the data collected on distress and looking at the overall pavement index, which with time it deteriorates. And they looked at two groups of projects, 5 projects on each, and a lot of data points. And of course, if you look at this set of data, for example, going to about 12 years, we still are way over the threshold of acceptable OPI. Now, we may not be very accurate, but one of the best tools we have is extrapolate through a regression equation, assuming that this data continues on a pattern of regression equation. And you would see that you get about 20 over 20 years of performance before you get to the threshold. And for the other case, extrapolation gives you something around 24 years. This may not be accurate, a little bit here and there, but it proves the concept. It shows you that these things, if they have been extending to 12 years here or 14 years here, and we are still way over the threshold, we will have a few more years to go before we get to the limit. And finally, SMA conference gave us also more confidence in terms of performance. Overall observation from the conference was that these can extend the pavement life 3 to 5 years. And you also see that from a lot of lab testing. I mean, people have been doing this SCV testing, ideal testing with SMA mixes, overlay tester, and the results pretty much consistently show that these mixes have a lot of potential to resist cracking better than conventional mixes. So perpetual pavements exist. SMA helps with that quite a bit, and there's evidence for both of them. So one of the things that we wanted to do was to look at 2 climatic conditions in Pennsylvania, one in the northwest of the state, Warren County area, and the other in southeast in the Philadelphia area. Both cold and freeze, with the difference that this one has long cycles of freeze. This goes to more frequent freeze thaw cycles. And see how the perpetual pavements function in these 2 areas based on modeling and performance prediction. The climatic data for these were obtained from MERA, and similarly for the distribution of the traffic, we used the existing information. We looked at heavy traffic situation in both cases for comparison. And we picked up a perpetual pavement structure that I'll show you in the next slide. Performance models, we picked up 3. One is Pavement ME because that's the most commonly used. Then we used Perroad, which is promoted by NCAT, and it was used in their work in developing their perpetual pavement concepts. And that is based on the limit of strain that I talked about a little bit earlier. And finally, we picked up another pavement model, prediction model from Tex ME, just as for a comparison for the Pavement ME. Dennis Morian, who was involved with this project, really handled the modeling part on the first 2, and we did the last one. So the structure that we chose, we picked up 14 inches of asphalt with the 3 layers that I mentioned, the top SMA layer, the high modulus rot resistant layer in 2 layers being 8 inches, and the rich bottom high asphalt 3 inches sitting on a crushed base at a subgrade, which for the subgrade, it is highly encouraged that subgrade be well compacted, well prepared to give you the support that we need. For a particular case we made it a seasonal variation in the range of 5,000 to 10,000 psi. So not necessarily very strong, but not poor either. We just wanted to have something in the average range. So when you look at the Pavement ME prediction on the rutting, you would pretty much see this. And this is the year. So we looked at a 50-year period because that's what the intention was, to see how it performs within the time frame of the definition of a perpetual pavement. And you would see that you are well below the threshold that was used for this purpose in the Pavement ME. For the bottom-up cracking, very minimal in terms of the developed crack after 50 years. If you look at the thermal cracking and within the 50-year and compared with your threshold here, that's where you are, about 270, 280 feet, linear feet in 1 mile of the road. So pretty much that shows you the excellent performance that you get out of the model for the structure that I showed you. On IRI, you do get into probably threshold values after several years. It doesn't go as far as 50 years. But if you look at where we get, for example, on this 95% confidence level, you would get there to around, what, 27 years. So it's over 25 years of performance before the right gets to a point where it becomes of a concern. With the per road analysis, you remember I showed you the threshold value that was developed by NCAT and tending to be for this is the same graph, except that this is simpler than the one I showed you with all the test sections of the research cycle. You have the strain developed at the bottom of the asphalt layer here. You have the percent cumulative strain here. And what you observe is that you would like to be to the left of this threshold value to be having good performance. And what you see here is that the prediction of the model was well over there for all the levels of strain and excellent performance. So no cracking is expected based on the per road run. On the text ME modeling, we made a comparison between conventional pavement versus a perpetual pavement. This one is on a conventional pavement. Dennis did a design based on Ashlaw 1993, pretty much coming with the same thickness of the layers as a perpetual, except that the layers are not per se the high modulus and the rich bottom the way we had them. And I believe that he had 1 inch higher, 9 inch of base rather than the 8 inch in this particular one. But the prediction that you get out of text ME shows that you get into pretty much significant levels of cracking within maybe 20 years period. And here is an example of getting to 20 years, 25%, for example. These are in month, by the way, so 600 associates with 50 years of service. Again, remember, we wanted to go through the 50-year period of this performance. Now, if you compare this with the perpetual pavement, you would expect the performance to be very good with very little cracking observed in the pavement, even after 50 years. You look at the rotting on the conventional pavement, you pretty much get to 1/4 inch of rotting based on this prediction after about 5 years. So this is a total rotting versus the layers. These are different layers rotting, and then when you add them all together, so this is the one I'm looking at here, the orange one, giving you the total rotting for that purpose as a conventional. So after 5 years, getting about 1/4 inch. Now, if you do the perpetual pavement, you get to that level maybe in double the time. So it takes 10 years to get to where you were in 5 years with the conventional. So the performance is there. So one of the items that was discussed heavily both by Tom and Buzz on the balance mix design, the need to balance between rotting and cracking. I don't get into that much, but that also goes hand in hand with the need to make sure your material properties are there to give you that fatigue resistance you need at the bottom and reach bottom. You can get the rotting resistance in the middle layer. And you wouldn't know that unless you really test your materials and you make sure you are getting what you want out of the 3 layers of performance in perpetual pavement. And there are many tests for this purpose. Again, I'm not going to go through these, but different states have different sets of these to work with. But the bottom line is that you need that testing to get the properties, and it's extremely important. Regardless of whether you use prediction models and for prediction of performance, if you even do not want to use that and you just want to build based on volumetrics and enhance your mixes, as Tom was talking about, you still would need that. I will show you a few examples of the recent work in Pennsylvania and pilot projects that some performance testing results have been obtained. And these will be monitored for performance. The testing, I believe some of these were done actually by Tom, if not all of them, at Rutgers. If you look at the Hamburg wheel tracking, very little track. I'll show you, this is SR28. I'll show you a few of them. All of them have SMA at the top, either 1.5 inches or 2 inches. Most of them are 9.5 millimeter, maybe 1 or 2 cases are 12.5. Similar more or less in terms of a structure. And if you look at the, so we look at 3 things very quickly. One is the rotting level. One is the low temperature cracking through the disc compact tension test in terms of the fracture energy. And one is the flexibility index for the intermediate fatigue cracking. Just quickly take a look at the numbers. And the rotting you would see here, for example, is very low, and flexibility on the crack is pretty high. And this is, as I mentioned, this is consistent for SMA mixes. That we have seen these numbers to be pretty much over 20-25 in terms of flexibility. And the energy very decent in terms of the cracking that you would expect. On SR322, similar 1.5 inch, 9.5, very little rotting, very high energy, again, very high flexibility. I-84, very little rotting, very high energy, very good flexibility. It just same thing for the other 2 as well. You would see the numbers there. The mixed performance, the laboratory performance testing on these mixes indicate very good performance. Now, once the monitoring data, the data is out after these pavements have been monitored and evaluated and assessed, it gives us an idea of where to draw the line in terms of criteria, just like what Buzz Powell was talking about in terms of the numbers that they have come up with in their work. One thing I should like to mention here, we talked about this endurance limit stuff and making sure that you limit the level of strains, tensile strain at the bottom of your asphalt layer, also at the top of your vertical strain, at the top of your subgrade. One thing that we really are missing big time with Ashlaw 1993 design guide and using our structural numbers the way we do is to be overly conservative, especially at high traffic levels in terms of the thickness of the layer that we get. And this is obviously because we are not accounting for the properties of the asphalt. If you use a structure number of 0.44, I mean, if you have a high binder, low binder, polymer modified, I mean, we're not taking that into consideration. And that is, we are at a point that we have the ability, with all the work that we have done, to come up with optimized design, a balanced mix design. And coming with the properties that limits the strain levels so that we can come up with lower thicknesses. And in many cases, this 0.44 structure number is very conservative. And work at NCAT and other work has shown that that's the case. And it just makes sense to get into this performance testing, getting into this performance modeling, looking at the strain levels rather than just continuing the path we have been on and coming up with conservative mixes. This is an example of bottom-up fatigue cracking that we try to limit based on limiting the strain level at the bottom of the layer. This is an example of the need to limit the strain at the top of the subgrade. The way this profile is with the cracking you see at the sides, it is easy to realize this is not cracking or rotting happening from the top layer of the asphalt layer itself. Rather, it is coming from the foundation of the pavement. The final thing I want to touch on very quickly is the life cycle cost analysis and comparing the cost of a perpetual pavement versus conventional pavement. So we looked at three alternatives here. We looked at perpetual pavement with the assumption that we do not need to go back in there and do anything to the pavement until 20 years later. With the second interval being 15 years later, going at year 35 and do a mill and fill of the pavement with a 2-inch SMA. The conventional, we assume that the need is there to go in there after 15 years, and then the subsequent alternate times to go in there are about 12 years. And this is pretty much in line with what we see in Pennsylvania. You also have a condition where you may not have SMA at the top. This one, for example, we assume we have SMA on the surface, but here we have a case where you are using conventional mix on the surface, and the need to go in there would be more frequent, going in there every 10 years to after the first time to rehabilitate the surface again. So we looked at these three alternatives, and we used the real cost analysis for this purpose to the Federal Highway Administration real cost analysis. So we went through several scenarios and alternatives for these pavements. And the initial cost of construction that I do not have in this table, the initial cost of construction for perpetual pavement comes up to be slightly higher than your alternatives. But when you look at the number of times you need to go back and maintain or repair the pavement, and you bring that cost into consideration, and then you add all of the costs together, and that would be the cost of initial construction as well as the costs associated with all the maintenance you do in future, you come up with a lower cost in your perpetual pavement compared to your conventional pavements. About 13% to 20% lower, depending on which one you're looking at. If you look at the present value, you bring all of the costs after your discount to the present value, you would see still that you are lower in all cases. And that also applies to your user cost. And eventually, if you look at the equivalent unit for annual cost, you would see you get a better picture of how the costs compare annually. And you would see that in this case, the perpetual pavement is cheaper overall compared to your conventional mixes. So in summary, what we consider perpetual pavement is pavement that lasts 50 years. I don't think it is a concept. We showed that there is a good track record of this throughout Pennsylvania as well as the country. We think that it is reasonable not to need any treatment if things are done right until 20 years later. And you may need very minimal maintenance, like minor cracks, to take care of during that time period. Performance prediction models are extremely important tools to look at design, because we are going with the concept of limiting the strain in these pavements. You do need performance testing, obviously, to get the properties and make sure you design your layers. Those 3 layers that I mentioned to you are the principal layers of a perpetual pavement, meet the requirements. And finally, we did the life cycle cost that showed that it is more economical. So overall, to make a few recommendations here, we do need to look at, for example, a 20-year. I think it's, again, as I said, it's reasonable to assume we don't need to do anything within 20 years, and anything we do after 20 years is helping doing something with the surface of the pavement. Subsequent intervals to do something would be 15 years. That's a recommendation here again. Important to jump into performance testing as soon as we can in Pennsylvania, and get that moving forward fast. That becomes part of our perpetual pavement design. And I did maybe mention briefly that subgrade and subbase need to be proper. A strong subgrade certainly helps with reducing the thickness of your asphalt layers. And I think the proof is 2 test sections I mentioned to you with 9 inches of pavement structure, asphalt structure, not having any cracking. And that only comes as a result of having a very good base there. We talked about the importance of endurance limit, and that really comes into your perpetual pavement prediction modeling. And I think with that, I stop here. I hope I didn't go over time. And again, sorry for the initial inconvenience in not getting this up and running. That should wrap it up for me. And if there are any questions, I'll be glad to answer.
Okay, well, thank you, Mansoor. A lot of good information there in a short period of time. We only had one comment, and that goes to the question was, and you were talking about perpetual pavements, and there is a perpetual pavement award. We referenced PennDOT's won that 9 years in a row, and maybe 10 years now with the one next year. The question, and Amy Miller talked about that when she gave presentations on Tuesday's conference. And the question was, can we submit the Blue Route down in Philadelphia for that perpetual pavement award? That was constructed in 1988. This year it'll be 33 years old. The perpetual pavement award criteria is that the pavement has been in service for at least 35 years. So the current perpetual pavement award, we're going to have to wait another year or two for submitting that one. However, Amy said on Tuesday that APA is coming out with 2 new criteria for perpetual pavements. One is in the design and one is in the rehabilitation. So maybe it would qualify for one of those 2 new awards also. So we'll check into that and get back to the individual that asked the question.
Okay.
There were no other questions regarding the presentation.
Well, thank you.
And as I said at the beginning, we gave a presentation to PennDOT, and they're considering the recommendations that were included in the report.
Yeah, Gary, I guess we could say if anybody wants a copy of the report,
We could send them the full copy.
we'll be able to. It's a 50-page report, so it's very well written, and it gives you a bunch of information. I think it's exciting that we used 3 different data points. We ran all the models. I think it was well done. Mansour, Denny, Maureen, and Gary really deserve a lot of credit for writing a report. And we'll see what happens with maintenance treatment cycles for long life asphalt pavements. We're all excited about long life asphalt pavements. It's not just the mix design, but there's a lot of other parts to a long life asphalt pavement specification and
Structural design also.
yeah, design, the structural design and construction and a lot of other things. So, but thanks, Mansour.
Sure. Thank you.
Very much appreciated. I'm gonna bring up our next presenter. I'm gonna let Gary introduce him.
Well, let me start by saying that the COVID pandemic has forced us all to change our norm. And we hear the term new normal all the time. And I would say that the one thing that fits a new normal probably more than anything else is we're doing a lot more things virtual, like this conference that we're doing today. So Lindy Paving Inc. from the Pittsburgh area has proposed to the department the idea of virtual asphalt acceptance testing, VAAT is what we call it, at their central laboratory out in the western part of the state. So we're going to have Greg Toman from Lindy Paving and Mark Gallardo from our District 11 office out in Pittsburgh to tell us about their current proof of concept project that they're doing on this VAT HOLA, if you will. Greg Toman is Lindy Paving's field QC manager. He is a graduate of the University of Pittsburgh with a bachelor's degree in civil and environmental engineering. He has over 20 years of asphalt paving experience, 21 of those with Lindy Paving. And Mark Gallardo, I said, was with District 11, graduated from Point Park University with a degree in mechanical engineering technology. And Mark has been with District 11 for almost 8 years, holding various positions in the materials unit. And Mark was recently promoted to the materials manager position in District 11 just a little over a year ago. So Greg, Mark, looking forward to your presentation. Give us a status update on that proof of concept project.
Okay, thank you, Gary. I'd like to give everybody a hey now that's still hanging on with these presentations. Basically, I'd like to flash back to March of 2020. The coronavirus is spreading out of control. Governor Wolf shuts down all non-essential operations, including construction, which is gearing up for the start of the season. Information and rumors start to spread about how long the stoppage will last, but no one really knows for sure. We find out inspectors are no longer able to visit plants and witness calibrations, as well as everyday operations needed to start the season. All this uncertainty leads us to ask the question, how can we continue doing our normal day routines and still test material locally underneath all the COVID-19 guidelines? So we came out with the idea of this virtual acceptance testing. So again, PAPA, we reached out to them to talk about the next step to do the proof of concept and come up with a specification. We ended up modifying an existing HOLA specification, with the major change being the samples be run by the contractor's employees and witnessed by the PennDOT representative. Again, this idea of us running the samples was to adhere to the COVID-19 guidelines and restrictions. The bad thing about this was we could only use this specification for 100% state-funded projects, since the current federal guidelines only allow DOT employees to run samples. So again, and with the gist of meeting all the COVID-19 guidelines, we came up with a potential list of projects that we could use that were 100% state funded, and we ultimately selected a group in Allegheny County. So why do we need VAT? It's going to reduce the number of samples going to Harrisburg for testing. It could be an option for any contractor. Again, we like the keyword here is option. This is not going to be a mandate, just another tool in our toolbox, as some would say. A quicker turnaround time for the best test results. So with the influx of samples from the shutting down of local acceptance going to Harrisburg and the taxing of COVID-19 restrictions, we felt that there would be a lull in the test results coming back from Harrisburg. So we felt that getting local acceptance back up and running was very important. Again, reduce the resources needed by districts and central office. Here we like the idea of an inspector being able to witness the testing from anywhere, that they had access to a computer or an iPad. This would save on time and travel for our testing facility. And the virtual aspect of it opened up adjacent districts to us and even the central office to be able to witness the testing at our central location. And also so that reduced their need for resources they didn't have. And the biggest one was to limit the exposure of the COVID-19. So central office approved the proofs of contest for VAT testing. We developed a pro team in order to have a conversation on how it's going to happen. District 11 approved a state-funded pilot project, and then we had to come up with a QC plan locally, and then our system itself in District 11 had to be approved by their materials manager. Just like HOLA, you would need an AASHTO assessment for the ability to do the HOLA and the virtual acceptance testing. And since we were in the middle of the pandemic, the AASHTO resource assessors were not allowed to come out and visit our location. So we told the assessor about our camera system that we're setting up, and they were very receptive to do a virtual assessment, which went flawlessly. And the assessor gave us very good feedback about the system. So that was the first test that we actually did using our system remotely. Again, the district would have to come and approve our VAT system. We felt that our system covered the ability of all aspects of the laboratory. So this was up to the district to say whether, hey, you're doing a good job, we can see you here, we can't see you here, and to approve that VAT system testing. Our system in particular has 11 4K resolution cameras, which the digital zoom feature is enabled so you can zoom in on the numbers. It does also have a 7-day recording capabilities, just like a security system would. It's web-based remote access. We use an independent audio system, which is our conference phone line that multiple users can call at the same time. And we found out that the best audio version was AirPods connected to your iPhone, calling into the conference line, so the users could have their hands free while they're doing the testing. When we set up the camera system in our central lab here, we set it up for basically all the testing we could do, which is not limited to all this stuff. So that's why we kind of oversized the camera system, not sure on what was all going to happen with the remoteness for testing. So we try to cover all aspects of the laboratory. And these are some of the test results that we can run. I'm not going to play you a short video to demonstrate the capabilities of the virtual asphalt acceptance testing. I'll kick it back to you guys.
Eleven 4K resolution cameras that capture all aspects
Is
of
that
the
over?
laboratory.
Is it coming through?
It also features digital zoom capabilities to verify numbers easily.
Yes.
I forgot to unmute myself.
We begin the process by having the secured samples delivered to the laboratory. These samples will be logged in by the testing technician. Next, he will contact his PennDOT representative to schedule a time and date to run the samples.
Coolers in place. Okay, verify coolers in place. Ready for the tag? Pull the tag. Tag secure. Go ahead and put the tag, Rob. Okay.
I don't unmute speakers.
Can you hear the video?
Tag for securing. Can you hold it close to the camera, please, Rob? You can? Okay, verified, thank you. Okay,
Are we getting any?
tag is secured. Verified, thank you, Rob. Yes, sir. Okay, Rob, go ahead. Okay, I'm gonna grab the pen, get it ready. Check the tag. Verified secure. Go ahead and cut it, Rob. Tag number verified. Will be sample 2-3. 2-3. Sample verified. We use basket 1. Basket 1. Tare weight is 3092.8. 3092.8. Yes, sir. Verified.
The technician will now quarter a sample and prepare it for the basket. After the sample is prepared in the basket, the technician will verify the weight with the PennDOT representative, making sure the numbers are recorded by both parties. He will show the ticket to the PennDOT representative to make sure all the numbers are verified. The PennDOT representative will use the cameras to follow the technician through the process to the laboratory. Anytime during the testing procedure, when information is entered, the technician will pause and also use a two-way communication system to make sure the PennDOT representative records and verifies the number correctly. After the sample has cooled for a period, the testing tech will contact the PennDOT representative to let them know the next steps of the procedure are ready to begin. Now that the sample has cooled, the technician will take the basket to the scale and get a final weight. The technician will then take the sample to the cleaning station where it will be prepared for the washing process. At any point during the testing procedure, if a problem arises with the camera system or the two-way communication system, the PennDOT representative can instruct the technician to stop testing and secure the samples immediately. The sample will be cooled for a brief period before it is ready for sieve analysis. The technician will weigh the pan and get it verified by the PennDOT representative, and then load the sieves for the shaker.
$1185.0. 1185.0. Verified? Yeah. It changed to .1, but I wrote .0, so we're good. $1259.6.
The John's questions for the last.
Rob, could you hold that stick back up, please, so I can verify there's no material in it? Verified? Thank you.
Man source, yeah.
Can I verify this one too? Thank you. Yes, sir. Okay. The weight is 1378.5. 1378.5, verified. Yep, and that was the last of it. Okay.
We now move on to the core density process. Much like the material process, the cores are delivered in a secure cooler. The tags will be verified to the PennDOT representative by the testing technician.
Verified here. Okay. Good to cut the tag? You're good to cut the tag. Tag number verified. Okay. We're going to start with pan 12. Verified. Pan weight 572.3. Weight verified on the pan. Okay. And we're going to go with core number 2-5. Hold it right there, Rob, please. I need to switch the camera. Core verified. Okay. $1390.0. Sorry. Weight verified. 2412.6. 2412.6, weight verified. Okay. And 12. Okay. Here's the tag for the oven. Tag number verified. Okay. Tag lock. Verified secure. Could you read tag number for me, please? Tag number is 2764404. Tag verified. Thank you. Yes, sir.
The next day, when the sample is ready to get its dry weight, the technician will cut the security tag, show that to the PennDOT inspector, and continue running the sample. This concludes our video on a virtual.
Okay, now I'm going to turn it over to Mark Gallardo from PennDOT, District 11, to finish the presentation. So Mark, whenever you're ready, take it away. Do a little sound check for us too, please.
Charlie, can you hear me?
Yes, sir. We can see your PowerPoint also. Thank you.
All right, sounds good. All right, like Greg stated, the VAT is a modification to our current HOLA special provision, and I basically wanted to add this slide just because there was a lot of confusion as far as whether or not we were meeting a lot of the core requirements of the HOLA special provision. The special provision states that for federally funded projects and projects on the national highway system, the department representative must conduct the testing. And then on all other projects, the department reserves the right to have acceptance testing performed by the contractor in the presence of the department's representative who will witness the acceptance testing. So the special provision already allows for testing to be performed by the contractor for 100% state-funded projects, non-NHS. But in the case of VAT, our materials inspector is just witnessing the testing via the cameras instead of in person next to the technician. So some specifics for our pilot project, which is ECMS 105248. We required the verification samples specifically for the pilot project so we can gather some data. We wanted companion loose box samples per sublot, and then this verification testing is performed by the department personnel. The number of tests basically depended on the lot size. If the lot is n equals 3, then the representative will randomly test one sublot. And then if the lot is n equals 4 or greater, then the representative will randomly test 2 sublots. And then the verification test results are compared to the acceptance test results. Again, this is specifically for the pilot project. We want to show some of the comparison results we have for a couple of the lots we tested. Again, this is for the pilot project only. We used the same tolerance for the IA samples in the original HOLA special provision. This is for lot 1 of the binder, and as you can see, the results were all within the tolerances. This is lot 1 for the wearing, and again, the results were all within the tolerances. The asphalt content test results were within plus or minus 0.3%. The percent passing the number 8 sieve were within plus or minus 4%, and the percent passing the 200 sieve were within plus or minus 1.2%. So a lot of people ask, why use the VAT HOLA? What are some of the benefits for using this option? So again, it's another option for acceptance testing in HOLA. This isn't proposed to be a permanent replacement for the standard HOLA, but just as an option. The testing can be witnessed virtually from anywhere. All that's needed is an internet connection and no stoppage or delays to acceptance testing. We certainly hope that there's no future shutdowns due to COVID or for any other reasons, but if there is, testing could continue. And last, potential cost savings for the department. Since the test can be witnessed from virtually anywhere, this means that less travel time and less travel distance for our inspectors. What have we learned so far, and what are our concerns? Our number one concern is the security. We want to be sure that the samples are secured. And as you can see from this bottom left picture and in the video, we were able to verify the security tags for the samples via the camera. But what happens if the cameras malfunction? This is something that our team will basically talk about after the pilot project is over to determine how we would handle that. Another concern is the efficiency. When our inspectors have to take their breaks and their lunch, the samples have to be secured again. Locking up the samples and then verifying the security tags could take a bit of time. And lastly is the equipment. As you can see from this picture, our department laptop screen is fairly small, and the cameras have to be up at all times to ensure that every part of the test is witnessed and the samples are secured. So only having the one screen prevents the inspectors from having eCams or maybe a spreadsheet opened up for entering our test results. So where do we go from here? The paving for our pilot project will be completed later this year. Right now, we're anticipating another 2 to 3 lots of samples. After we complete our testing, we'll conduct our after-action review with the team to basically determine what worked and what didn't work, and more specifically, determine how to handle the connection loss during testing. Should the cameras be allowed to record the testing? Do we use FaceTime or some other type of video calling on our phones to witness the samples being secured? Also determine the minimum equipment required. We did for this pilot project, we really didn't specify the number of cameras required. Obviously, we felt like this would depend on the size of the lab. In Lindy's case, their lab was very spacious, and there are a lot of different areas for different specific tests. So they wanted to have 11 cameras. So obviously, the size of the lab would determine the amount of cameras. And finally, we'll make necessary changes to the special provision and have it go through the clearance transmittal process again, and then obviously we'll finalize the final special provision. Potential use of other systems. I wanted to add this slide to briefly talk about the potential use of other systems for witnessing the testing. I know central office is currently looking at a couple remote visual inspection systems for use on other applications, more specifically this AMA Expert Eye and Imagion. There's currently a remote visual inspection system specification used in District 6. The application is for virtual inspection of their fabricated structural steel. It's my understanding that the smart glass system will be sent to District 11 later this year, and that the materials unit will be able to use it. So depending on when we do get this system, we can utilize it for the remaining dots that we have for this vat hole pilot project. And then again, this is just the viewpoints of all the different cameras that Lindy has in their lab. And with that, are there any questions?
Greg and Mark, we don't have any questions here. Excellent presentation and demonstration. Just a summary that this is an option. It's not a requirement. And as you do the AAR and come up with your revisions to your standard special revision, I know you're going to try to keep the equipment requirements as general as possible. So it doesn't necessarily have to be a look-alike to what Lindy put up. And another thing is that this is for 100% state-funded projects where the department can witness the testing and not actually do it, which is a requirement of FHWA. So again, thank you very much for the presentation and for the good work you're doing on this pilot project.
Yeah, this is Charlie. Let me just say one thing. Whenever we get into tough times, either with funding or now with the pandemic, what happens? It drives innovation. It drives us to look for different ways of doing things, and this is pretty exciting stuff. I think FHWA, AASHTO, NAPA, other state DOTs, and of course PennDOT, are looking for to innovate, to make things more efficient, and also to make things safer for all their employees. So, and you also got to look, this initiative pretty much was put forward by Lindy Paving out Pittsburgh, Zelienople, that area. I mean, this is pretty exciting stuff. So thanks to PennDOT District 11, Mark. Thanks to Greg. Of course, I have to say, Lindy Paving again, 5-time Sheldon G. Hayes Award winner too, and of course District 11, the project that they're going to get it in a couple weeks here from Napa was in District 11. So congratulations. I know Mark was part of that also. So thanks, guys. So next up, we're going to have a finale, the finale by Richard Willis. Let me do a quick intro of Richard, and I'll do a sound check. Richard, your presentation looks good up on the screen. But Richard Willis is, I'm going to do his introduction. I'm not going to talk his bio, but his introduction is pretty interesting. Richard is the father of a 4th grader who believes he will become the next YouTube Minecraft sensation, a 3rd grade girl who thinks everything in life needs more glitter, and a preschooler who still does not understand why a dinosaur would not make a good pet. Richard enjoys good food, helping his kids learn math, of course pre-pandemic, of course, and sleeping whenever his family lets him. To support his love for his family and good food, Richard is the Vice President for Engineering, Research and Technology for the National Asphalt Pavement Association, where he assists the asphalt industry with issues related to recycled materials and asphalt mixtures, pavement vehicle interaction, pavement design, and environmental product declarations. Just like a good mixed design, he tries to promote balance in all areas of life. He has a deep passion for education and tries to ensure that people remember the message, even if they forget the man. And I'd just like to add, you saw Richard is a PhD before, and I'm not going to go through his vitae anymore, but I just want to say, before he got the job at NCAT, he was a associate, or before he got the job at Napa, he was an associate professor at Auburn University at the National Center for Asphalt Technology. So Richard, I'm going to turn it over to you. Do a little sound check. We'll make sure you're sounding good, and then we're gonna let you roll.
Thanks, Charlie. Everything sounding good?
Yes, sir.
All right. Well, thank you again thank you for allowing me to be a part of this meeting today. I was actually up there with you a couple of years ago at the Hershey Hotel, giving you a Napa update specifically around some of the Pavement Economics Committee work that we've been doing. And I appreciate the hospitality that you've always had for me when I've come to be a part of y'all's meetings. Today, Charlie asked me to speak briefly to y'all on a topic that, I'll be honest, 2 years ago, if you had told me it was going to take up as much of my work as it has over the last few years, I would have chuckled, I would have laughed, and I wouldn't have thought that it was going to be happening. But the reuse of plastic waste and asphalt mix has become a very, very important topic, not just for our industry, but it's become an important topic for the plastics industry. It's become an important topic for the general public. And I think without prognosticating what's going to be happening over these next 4 years, I think this is going to be an important topic for the current administration and what's happening as we look towards highway reauthorization and some of the greenhouse gas emissions goals that are being set for by now President Biden and his team. So before we really dive deep into this presentation today, I wanted to step back and just briefly remind everyone who or what NAPA is. If we look specifically at the mission of NAPA, we have three goals, or we have three parts of our mission. It is to support the industry and support the businesses and our members by helping them understand risks, by helping them learn best practices, by helping them in ways that can make their businesses run smoother. We also advocate for the industry, and whether that is in the U.S. Capitol, maybe virtually the way we're having to do it these days, or with Federal Highway Administration, even sometimes with state DOTs and state legislators, we want to make sure that our industry's voice is heard loud and clear, and that we can not just advocate for the industry, but find ways to partner with these organizations and these groups to ensure that the best interests of both parties are met. But then we also want to advance the industry. The construction industry kind of has a bad rep in many ways for being a stick in the mud and not really advancing technology and not moving forward and being slow. And we really believe that dynamic changes in the industry can make us better. It can make us more competitive with other pavement type materials. It can make us where we're giving better products to our customers. And so whether that is looking at things like balanced mix design or e-ticketing technologies, we want to ensure that we're taking technology and other advancements which are in our reach and applying them to make our industry better and move us forward. So with that, we start to think about this specific topic. And if we look at kind of an outline for this presentation today, I want to start off by, again, kind of giving you a brief onset of what's going on. What are we seeing on a state level, on a national level? Then I want to talk a little bit about plastic. As many of us have studied engineering, specifically in the civil field, plastic isn't something you necessarily take a course on to get a civil engineering degree. And so we need to understand the complexities of it, and we need to understand really what's even available today. Then we're going to take a step and learn, what do we actually know? There are a lot of people making claims regarding what recycled plastic and asphalt can do. And so we're going to take a really sober look at what do we know, and then what do we not know? What are still those knowledge gaps that are going to make us more comfortable or make us realize we need to put some effort into maybe trying to find a better solution. And then finally, we'll end with kind of what I suggest and what I'm advocating for as the path forward on this. So as we dive in, the first thing I think we really need to set the stage on, and I think this is something that we're really going to need to focus on over these next 4 years, is the FHWA recycling policy. If you look, the FHWA recycling policy was last updated in 2015. And while there are 5 major kind of bullet points on how they encourage people to recycle and how they encourage the reuse of recycled materials in different infrastructure projects, there are really the 3 E's that they focus on. And that is if you're going to use a recycled product, there needs to be some kind of engineering benefit to it. It needs to make engineering sense, and it's not just something we're adding in and it's going to detract from the life of the pavement, or it's going to make things harder in the future. The second E is the economics of things. If I'm putting in a recycled material, but because it costs me so much to process it and get it into a position where it actually can be a viable solution, does it make any economic sense? If I'm driving the cost of my pavements up, maybe there's a better solution somewhere else that will still make an engineering sense, but it'll also make more economic sense. And then finally, it needs to make environmental sense. And that's, yeah, maybe taking all this material out of the landfill, but are there any other environmental ramifications that could come through the use of me putting this into an asphalt pavement, or really any other type of pavement or infrastructure material? And so while we look and we're hearing a lot of things in the media, we're hearing a lot of push for things like greenhouse gas reduction. I think that that's something as an industry we're going to be looking at, and we're going to be trying to understand what part can we play in helping reduce greenhouse gas reduction. And I think we need to understand that it all has to be balanced with the engineering side of things as well. Really, how does it fit in terms of performance? And then how does it fit economically? If it drives up my cost a little bit and it improves the life of my pavement a lot, maybe that makes economic sense. But if it drives up the cost but doesn't impact performance in a positive way, or maybe even it impacts it in a negative way, is that really the responsible way to recycle? I remember as a kid, one of my first jobs at the house when I lived in Waldorf, Maryland, was we would collect all the aluminum cans, and I'd go out into the garage with a sledgehammer and just smash them down so we could put them in a bag and take them to the recycling. And I thought I was doing my part to help the world. And I didn't think beyond, well, what happened to that aluminum when I handed it off to someone? What's really the life cycle impact of that product? And I think that's the shift that we have to do. It's not just is it good, is recycling good, but is it the responsible thing for us to consider? So when we start looking at kind of plastics, what really brought a lot of this to the forefront was in 2017, China, which was one of the biggest importers of waste plastic in the world, decided through the National Sword Policy that it was going to shift its focus, and it was no longer going to accept waste plastics from around the world. Well, if you look at this graph, which was put out by the EPA in 2020, and it only goes through 2017 in terms of numbers, the U.S. was putting out around 36 million tons of waste plastic a year. Now, we did use some of it in terms of combustion for energy recovery, but there's even pieces of legislation out there right now that are proposing that they're not going to allow people to do that or build new facilities that can use waste plastic for energy anymore. There was some of it that was recycled, and that's not much. If you look at kind of our national average, it's been around 8 to 9% recently. But the majority of it, around 26 million tons, was landfilled. We sent it off, we put it in our landfills, and then just waited for it to decompose over time if it could. Well, as we started thinking about China no longer taking our waste plastic, it was kind of the perfect storm, because we started to see at the same time a little bit of what I would call some of the few times asphalt's gone viral on social media. And in fact, I remember sitting in my office one day and I got an email from my mom with a Facebook post talking about the creation of plastic roads. And I kind of laughed, in all honesty, because I just sat there and thinking, I was like, is that really even going to work? What are they trying to do? But the problem was, it was a really slick piece of marketing. It looked good. And my mom, who is a biologist and has no background in civil engineering whatsoever, thought, hey, could this potentially work? And we started seeing other groups. There was a group called 100 Women Strong that put out a social media ad and video about recycled plastics and asphalt. Then we started seeing traditional media start to pick up this idea. The Washington Post wrote an article about it. The Economist, an article that you would never think, a magazine you would never think asphalt would enter into, wrote an article that basically said, asphalt's a polymer, plastic's a polymer, why can't we just separate it? Why can't we just swap the two out and then everything's going to be fine? I knew this was going to be a considerable issue for the industry, though in late November of 2018, I was sitting in Raleigh, North Carolina at a course or training regarding performance testing, and I got an email from Jay Hansen, who's our Executive Vice President for Advocacy at NAPA, and he said, you need to look at this. And so I followed the video link to see a hearing that was taking place, and the hearing was called Addressing America's Surface Transportation Infrastructure Needs. And at that time, Senator Barraza from Wyoming looked at a contractor from Texas and said, so a few weeks ago, we were hearing about this plastics problem and all the plastic waste that we have floating in the ocean. What's your industry doing about recycling? And while the contractor was able to answer about the great things our industry is doing related to wrap, or what some places are using recycled tire rubber, we didn't have an answer regarding plastic. Around the same time, we had started having conversations with groups like the American Chemistry Council that set goals that by 2030, basically every piece of plastic was going to be recyclable. And by 2040, every piece of plastic was going to have an in-market opportunity or an in-use where it could be recycled into something. The Plastics Industry Association had been starting some work within CAT about using specific recycled plastics in their mixtures and how do they perform and how does this impact the binder performance and how did it impact settling or separation. And we knew this was coming to a head. So we knew that we were going to have to look at it. And I was thinking back about the ideas that we've had in the past and the experiences we've had as an industry regarding recycling. And if we look at the different kind of experiments we've had with recycling, we can first look at wrap, the material that we've probably been recycling the longest. And if we look at where we are, we started recycling wrap over 50 years ago in our mixes. And today we're at around 22% as our national average. Now, we've had some ebbs and flows with the success of using wrap. And there have been times we tried to push it too fast and too hard. Maybe the technology wasn't available at our plants, or maybe we didn't understand the science of how everything worked. And there have been times where we've gone up with our wrap percentages and we've come down with our wrap percentages over the last 40, 50 years. But now, through time, through investment, through partnerships with other organizations, and lots of research, we're starting to understand how do we balance performance with the use of wrap and get good performance out of these mixtures, because ultimately that's what we want. With shingles, and it was really in kind of the 2008, 2009 standpoint where people really started looking at shingles. And why? Because the price of asphalt binder and polymer were going through the roof. And people wanted another option where they might be able to cheaply put in an asphalt binder substitute and move on. Well, it sounded like a great idea. We did some small experiments, but then people started pushing 7. There are even some documented cases of 10% shingles and mixtures. And then around 2014, 2015, we start to see some failures. We start to see some issues with some shingle mixes. And then immediately, when we track recycled materials in our surveys, we start to see just a plummet around 2015, 2016 of shingle use in asphalt. Now, I'll say this. If you do your due diligence, if you design your mix well, if you take care during production, construction, there's a lot of evidence that shows the shingle mix can work. However, what happened was we got out ahead of ourselves. There were some places that were not doing the quality control that they wanted or should have been doing. There were some places where the specs got ahead of the science, and we saw a pushback or we saw a backlash on that. Even with recycled tire rubber, people have been using this in different methods and ways since the 60s and 70s. But in the early 1990s, when Congress mandated its use, what happened? A few years later, Congress said, yeah, we're going to pull that back and we're going to rescind that mandate, because there were times where people might not be able to get the rubber. The plants weren't set up to be able to use it properly. We didn't understand how to use it in the different types of mixtures that we had. And when the politics got out ahead of the engineering, it caused problems, it caused some failures. And there's still some DOTs, because the failures that happened in the early 90s, they won't look at rubber. It's a non-starter. And so when we get to plastics, we have to understand this may be, it may be an option. It may be a great story that we can one day tell that, yeah, we're helping pull plastic out of the ocean. We're helping divert these plastics from our landfill, but it has to make engineering, economic, and environmental sense. Is it the responsible thing to do? So when we think about plastic, and this is one of the things that it makes the marketing really slick and makes the messaging really easy for the general public, but it causes the engineers that are having to develop this and use this kind of ulcers, is people talk about just use plastic. But in reality, there are lots of different types of plastics, and they all have different chemical and physical properties. And as we're thinking about putting these in our asphalt mixtures, we don't have a clue as to which ones will actually impact performance. Do I need to understand things about like the glass transition temperature? Do I need to think about melting point? Do I need to think about the chemicals that are involved? Because there are really 7 different types of plastic out there that are classified. But in reality, there are times where these plastics are in films that have different layers. Sometimes they are contaminated because they've had food or other materials on them. And I have to understand, how do I get a material that I can be confident in if I'm going to be using this in our asphalt mixtures? Again, ultimately, because as a contractor, I want to do everything I can to ensure that that mix is going to meet my customers' desires, which is it's got to perform. So when we look at the market that's out there, or we break down kind of what's in our municipal solid waste, around 30% of it is the low density, linear low density, or high density polyethylene. And really that's where the majority of the work is probably being found. There are some things that we know it does not ever need to go through a hot asphalt plant. There are some plastics that if I put it through a hot asphalt plant, it's never going to melt. It'll act as a filler, or it may act as a quasi kind of aggregate. We don't know, because we need to do additional research on that. But we need to be thinking about, of the plastics that are out there, of the plastics which are available, which ones, if we are to move forward in this, are the right ones to be thinking about. And so that gets down into a lot of the plastic recycling efforts. Now, there are basically 4, and I'm going to kind of gloss over this a little bit, 4 basic processes for recycling. There's a collection, and sometimes that collection then includes a separation of the different types of plastics. Sometimes people ask that you do that up front at your household, but then we take these plastics and we have to shred them down. We have to get them into a size that's going to make sense for our plant. One of the things that we've determined with the use of shingles is the smaller that shingle gets ground, the better we're going to get probably in terms of actual incorporation into a mix and performance. And I don't know if that same thing applies to plastic or not. Then that has to be washed, it has to get clean, and we have to decontaminate it. There was a study that came out that showed if we're going to move towards these plastic kind of recycling goals, whether it's in asphalt or whether it's in anything at all, you're talking about billions of dollars in terms of investment into the infrastructure of plastics recycling. There's going to have to be a significant uptick in what we can do to make this happen. Now, there are people that are making these issues and making these initiatives to move forward and help with this. But I think it's also important to understand, at the current state of what we have, it's not like something I can implement right away and just now every asphalt mix would have it, even if we had all the knowledge to make that decision. We have to have an infrastructure in place, just like we do with milling and processing our wrap, to ensure that that plastic is collected, shredded, and processed in a way that's going to work in our asphalt mixtures. So, as Charlie mentioned earlier, I come from an academic background. I worked with got my PhD with Dr. Dave Tim at the test track working on pavement structural design, and then moved into a lot of materials work after that. And in academia, the first thing, if you don't know what you're doing or you're moving into a new research realm, you got to do a lit review. And the great thing about being in my position right now is I don't necessarily have to do the lit review, and I can maybe pay someone else to do that lit review for me. And so we hired the National Center for Asphalt Technology, specifically Dr. Fan Yin, to lead this effort and see what we actually knew about the use of recycled plastics in asphalt. It was not something new. We tried this before. And so the Asphalt Institute and NAPA came together through the help of the SAPAs as well to develop these documents. And so briefly, I want to show you kind of the scope of what we were looking at. And there were over 110 articles that were summarized as a part of this effort, going all the way back to 1991. Now, what you can see is the majority of them have really come in these last 5 years, where we've seen over almost half of the information developed, which again shows we're starting to see an uptick or reinvigorated interest in this topic. And I think we're going to continue to see it for the time being. When we look at where these projects took place or where this research took place, most of it was in the United States. Part of that was because we did require that we did make sure that the articles could be read and they were in English because we did not have full translation capabilities. So there were some that we could not use because of language barriers. But 22 were from Egypt, from the United States. There were some from India. We saw a few others from Malaysia, China, and then there were a lot of what I would call people that were just kind of fiddling around with this a little bit and looking at kind of one-off studies. But again, it shows. It also shows that there are a lot of countries that are looking at this issue right now and thinking about it and moving ahead with additional research and additional work. As mentioned earlier, polyethylenes are the major source of what's being studied. 80 of these articles focused on either linear low density, or high density polyethylenes. Again, and part of that is because some of these other materials which you might be able to recycle into an asphalt mix, they already have sources or end opportunities which they're profitable, they're easy to do, and so finding a way to use them in asphalt may not make sense from a recycling standpoint. But some of the polyethylenes are not as easily recycled into other materials. They would actually melt at your asphalt plant. And so that, I think, is a reason why a lot of the literature has focused on the use of these specific types of plastics. Now, there are different ways that plastic is introduced into asphalt. We'll talk about that briefly in just a second. But the majority of the work was done through what we call a wet process, or that is where, similar to like a recycled tire rubber or a polymer, these are actually the plastic is blended together with the asphalt binder, either at a plant or at a terminal where it is now acting as really a binder modifier. There are some places that are using the dry process. India is specifically one of those, where they are basically introducing the wrap on the conveyor going into, or the feed going into the asphalt plant, and they're saying that it then coats the aggregate, makes the aggregate stronger. We're doing some work to see if that's actually the case right now with NCAD. But again, those are really the two primary ways that people are looking at the use of recycled plastics in asphalt. And as expected, most of this was focused on lab work. There were people that dabbled in things like pavement design, accelerated pavement testing, agency specifications, and even some field work. But a lot of this was lab kind of bench analyses. So let's briefly move through some information about what did we find out as we dove into this effort. Is the first thing we have to consider is how are we going to introduce this into our mixes? Are we going to blend it with a binder, or are we going to introduce it as through another method into our plant? Well, when we look at the wet process, the challenge that I see out there is there are two different schools of thought that people are having, and no one can necessarily agree. There are some people that are using it and saying, Well, really, it's a binder modifier. It's changing the properties of the binder, similar to what we would say with a polymer or some type of other additive. However, there are some groups that are saying this is really a binder replacement or a binder extender, which means if I were to introduce plastic into this binder, I actually need less of that binder to get performance, or less of that actual asphalt. I haven't seen a lot of evidence that shows I can reduce that asphalt content. And I think it's going to take some additional research and additional testing to see if that's really the case. But when we look at the wet process, people are typically thinking, I'm going to be using somewhere between 2 to 8% by weight of the binder of plastic in this modification. If you're also looking at the wet process, you need to ensure that you have a plastic that has a low melting point. And that is to ensure that you are being able to get as much of a homogeneous process as possible. Now, when you're looking at the dry process, there are some people that say, well, maybe I can use this as an aggregate replacement. I don't necessarily need to get as much raw material from the ground. I can use it as a lightweight aggregate and get performance out of it. This is an area, again, where there's not a lot of research. And I think that people are going to have to look at this a little bit harder. What other people are saying is it basically becomes a mixture modifier. So while I'm entering it dry and not necessarily blending it with a binder ahead of time, it is modifying the properties of the mixture to make it stiffer, to make it, quote unquote, stronger, as some people are saying. Other people, like I said, in India, they're saying it's an aggregate modifier. So maybe I could use it, and if I had a lower quality aggregate, this plastic coating that's surrounding it would actually, one, prevent absorption, and it could make it where that aggregate may not abrade as much in the drum. When we're looking at these types of plastics, we're seeing that people recommend anywhere between like 0.2 and 1% by aggregate weight, not by weight of the binder as we saw in the wet process, but really by weight of the aggregate. So again, it's something that may be hard to control from a process standpoint. We did see a lot of work on laboratory binder testing, and I'll be honest, the results weren't shocking. What we would expect to see is when we add something like this to the binder is it stiffens the binder. What does that mean? It means in rutting performance, it was great. We did not see rutting issues when it came to this type of binder testing. However, what we did find was there wasn't a lot of fatigue binder testing on this material, and there was very little data on actually the low temperature properties of the binders when we used a wet process and mixed the plastic with the asphalt binder. These are actually probably the areas that would concern most DOTs the most, because when we start thinking about, specifically, I lived in Auburn, Alabama for about 14 years, and when I had a plastic chair in my backyard, after 2 summers, it was done, because it, over time, just the sun, the UV radiation, changed that chemical structure within the plastic to where it became more crystalline, and it made it easier to abrade and easier to break down. And so I think this is an area when we start looking at binders, we really need to understand a little bit more. How does it impact fatigue, and how does it impact low temperature performance? What we also saw was if we thought recycled tire rubber had issues with separation, plastics takes it to another level. We started to see at times when you look at the cigar tube test, 40 degrees C difference between the top and the bottom of that cigar tube in terms of separation, where all that plastic had come to the top and it completely floated out, and it was almost a different material completely. There have been some additives through testing that have shown to help reduce this, but if we're looking at from a storage stability standpoint, this has got to be a concern, and this is something that has to be addressed. One other concern, if you're really thinking about moving forward, and there are some states that do require, especially when we start looking at recycled materials, doing chemical extractions, doing things like delta TC to look at what the binder performance is going to be. Polyethylene is insoluble in many solvents, which means if I were to do a chemical extraction on it, I'm not going to get the polyethylene at the end. It's going to be left alone, and it's not going to really show the impact of the performance on the binder. So we may have to think of a new way to test this, and whether that's testing the mixes or finding some more advanced ways to get the polyethylene back into the binder. It is something to consider. When we look at mixture characterization, again, it goes back, there were a few things that were kind of no-brainers that we saw, and we're glad sometimes the evidence proves our hypotheses out. Most of the testing was done through Marshall stability. And with the Marshall stability test, people saw increased stability. Additionally, people saw increased stiffness, increased rutting resistance. Now, it's interesting that there are different theories about why this rutting resistance is increased. If you look at the wet process, the obvious answer is I've got a stiffer binder. Now, through the dry process, it goes into that I don't know if I'm necessarily modifying the mix or if I'm really changing the aggregate. And so there are people that say the dry process, you're getting increased rutting resistance because you're increasing the friction between the aggregate particles, which gives you a more stable mix. Now, again, these are theories which we're hoping to have in the very near future a few more answers to how this is, what are the mechanics on how does this actually work. In terms of moisture damage, people either saw a positive impact where it was a little bit less resistant, or it was a little more resistant to moisture damage, or there was really no impact whatsoever. Now, as a group representing contractors, I think about not just performance, but how am I actually going to make this happen in reality? And when we look at plant operations, there's not a lot of information out there. And so that's one of the things that we're encouraging people to do as they look at demo projects is really document how does this impact your operations at the plant? Because really the information that we have is based on a product called Asphalt, which came out in the 90s and doesn't really even exist anymore. With that, they had to bring a high shear blending unit, similar to what you might see with like an Arizona style rubber mix, to the plant and produce it that way. From a construction standpoint, which is again also important to us as a contractor and even as the DOT, because we know density is so important, there was really only one study that documented construction. And what they found was it was a little bit difficult to impact. It required a little bit heavier rollers on this specific mix, but then they were able to get density. We talked to some group of an industry company that's done some work with plastic mixes in France. And their response was, these mixtures are temperature sensitive, which means they may cool off a little bit quicker. They may not hold the temperature as longer. But they found as long as you get on those mixtures quickly, compaction hasn't been an issue in their experience so far. So again, this is still something that we're going to need to learn. We're going to need to understand. And it's going to be important to document and do trials to ensure that if we're putting these things on the road, even as demos or trials, we're ensuring and putting them in the best chance to get the quality that we want as expected. Some other areas that we don't necessarily always think of right off the bat when we're looking at new products, we typically think about the engineering, those issues, but these are really ones that really rise to the top of importance is health and safety. There are two potential concerns that we see in literature, and one is the potential leaching of toxic components. And that is, it's something that is difficult to study. One study suggested that there's really no adverse impacts, but something that we need to continue to evaluate. The other thing that we found is when you're if people use PVC, there are chlorine-based gases that become off gases from that, and we need to avoid that. So PVC is not something that is recommended for use going through a plant because of the health and safety risks which could be associated with it. From an environmental side of things, yeah, there are probably some environmental benefits. If I'm using this as an ag replacement, I'm preserving resources. I'm reducing the solid waste by not making it go to landfills. There may be even emissions reductions based on all of those things if I do a life cycle cost or a life cycle assessment. But there may be environmental concerns. There's been a lot of concern recently about microplastics and how they impact the environment, how they could impact human health. We don't know if when we're recycling these, if microplastics get put into the air and could make us change our milling operations. There's the future recyclability of these mixtures. Is there a point where if I'm using 1% plastic, it's fine, 3% plastic, it's fine, but at 7% plastic, I can no longer recycle these adequately, and I now have to landfill this material. So instead of having 36 million tons of plastic that I'm landfilling, I'm now landfilling the 89 million tons of wrap that we use every year instead. So I'm solving one problem, but potentially creating another. And there is a lot of ongoing work in this. Federal Highways is conducting a life cycle assessment on all of this right now. And hopefully in the near future, we're going to be learning more. I heard there was a presentation at TRB this year on this, but I have not been able to attend that and see that yet. There are field projects which are happening. If you look at literature review, there are 200 field projects that have been documented. And what we saw was improved rutting, but more cracking. But again, a lot of these were done in the mid to early 90s. And we've started to see a lot of new field projects come out. India, Australia, Canada, New Zealand, the United Kingdom, and in the United States, we've started seeing a few demo and a few trial projects of some of these different materials around. And it's really important that we don't just put it down and let it be, that we take these opportunities to study and to answer questions, because there are a lot of knowledge gaps that are still out there. For example, I don't know how to source plastics if I'm a contractor or a DOT. How do I write a spec to ensure I get the right type of plastic in my mix? Because we do see that there might be some performance differences if I have a plastic that can't melt going through a plant, or if I'm using it in a dry process versus a wet process. In terms of the method of incorporation, I need to really understand, is it a modifier or is it a replacement? Because those are two very different things for me, and it can mean a lot in terms of performance of my mix. I need to understand, do the current binder characterization specs that I have actually work for this? Or because it's a different type of material, do I need a new type of testing mechanism to understand how these materials are impacting the binder? The same thing's true with our mixture characterization. And one thing that's really important to understand, there are a lot of places out there that are saying, we're getting 10 times the strength with a plastic mix. They're not long-term aging that binder. They're not, there's very little to none evidence out there of people that have done laboratory characterization with long-term aging. And with plastics, that is really important. Some of the early field projects showed that, you know what, cracking wasn't bad for the first year or two, but then once that thing started to crack, it got brittle and cracking accelerated greatly. So that long-term aging is really important. I need better understanding of things like plant operations. If I've got a lot of fine particles that are plastic particles that are going into my plant dry, are they going to get pulled through and gum up the baghouse and make it where I have challenges there? Construction, is it going to make it harder to compact? Is it going to require me changing the way I run that operation? In terms of H&S and environmental, we have to ensure that it makes sense for the work, for the health of our employees. That is something that is a non-negotiable. We have to keep our employees safe, and we have to ensure that things we're putting into our mix are not going to put them at risk for issues into the future. And from an environmental side of things, does it work? Does that environmental component make sense? And when all these questions are answered, we can't forget that it has to perform. If I put it down in the field, I have to be able to design it. I have to be able to produce it. I have to be able to haul it and compact it. But it has to perform. And if it doesn't, it's not the solution we're looking for. It's not going to help move the industry forward to be more sustainable. So moving forward, I really recommend, there are three things that I stress. One, patience. There are some things that we know now, there are some things that we're learning, but these research doesn't happen overnight. And we have to understand that a lot of different groups looking at this. And if we're all doing this in a collaborative way, we can have different groups solving different problems or answering different questions and moving this to where we have a better understanding or a better confidence of, is this something that is going to be a part of the asphalt industry's future? it's going to take partnership. And I'm talking outside of who we typically partner with. It's not just the DOTs, it's not just the asphalt industry, where you got to get people who understand plastic chemistry and rheology and all these different types of science, because they're not things that I understand or know well on an everyday basis. It's got to take communication. You know, when something succeeds and we can learn from it. But one of the things that you're not going to find a lot of in a peer-reviewed journal is a failure. We promote our successes, we hide our failures. And in reality, those failures are where we can really learn, and we can keep people from making those mistakes. As a DOT, as an industry, we have to be open to when something goes wrong, especially in these experimental phases, knowing that we're going to have some highs, we may have some lows. We have to be open to sharing those things of what went wrong. What can we learn and how can we advance? And if we don't have the patience, if we push this too far too fast, if we're not all in this together trying to see and answer the question, is this responsible? And if we're not openly communicating, it may be longer. We may have forced legislation. We may have something come our way that forces our hand to move us into a position that is not good for the long-term performance of our infrastructure. In reality, whether you're a contractor, whether you're an agency, whether you're an engineering firm, a material supplier, that's our responsibility. To put something together, build it and produce it, that's going to give us the best performance that we can have. So if you're interested in this, I would recommend, we've got 2 documents that are on the NAPA website and the online store that are free for anybody. We've got a state of the knowledge document, which is about 30, 40 pages. It summarizes a lot of what I talked about today. If you're a glutton for punishment, there's a lit review, which is article by article, those 110 plus research documents. What did they say? A summary of it, what type of plastic they used, how much plastic they used, and what do they learn, and what are really, what's the scope of that analysis, so that we could understand what we need to do kind of moving forward. I'd be remiss if I didn't take this time to also invite y'all to be a part. NAPA's got an annual meeting that's going to be done virtually this year coming up, February 16th through 18th. You can go to NAPA's website to find out more on this. We're going to be talking a lot about the state of the industry, what funding looks like for 2021 and beyond. We're going to be looking at sustainability, resilience, and even some different approaches for mixed design. If you've got people that you need training for and they need information on how do you run your plant, how do you handle your crew, how do you compact your mix. As a part of the World of Asphalt, NAPA's always had the people, plants, and paving. But since World of Asphalt's not happening this year, we're taking that training for your crews virtual and putting it in an online environment where in 3 days they have the opportunity to get to look at over 60 sessions, that whether you're an HR professional, whether you're a foreman, whether you're a mixed design specialist, we have content to help you do your job better and learn from people that are in your shoes. We would invite you to be a part of that. And with that, again, I want to thank you for allowing me to be a part of this. This is a really important topic for the industry, and I hope that you've been able to get a little bit out of this time today. Thank you.
Hey, thanks a lot, Richard. I think you'd get a pretty big round of applause if you know, we didn't have everybody out there on mute. So that was pretty excellent. I know Gary and I, as old PennDOT 35-year employees, we dealt with everybody wanting to recycle things into asphalt pavement. You know, the one thing that we found over the years is the asphalt rubber, tire rubber, if done right, really enhance performance. You know, we tried glass, cullet, you know, and I guess PennDOT still allows it to be used in the base to a certain extent. But the one thing I harken back to is when I first, this was 1978 when I started for PennDOT, one of my first jobs was to document all the projects where PennDOT had put asbestos fibers in the mix to try it out. So I had to go out and document all those projects and in District 8, which is the Harrisburg area, of course, for PennDOT. And I think there was like 12 or 14 of them. And every district did a whole bunch of these. So there was hundreds of them around the state. And PennDOT still hasn't taken all that pavement out that has the asphalt fibers in. I think that, or the asbestos fibers in. PennDOT District 8, I think, just finished the last project like 3 years ago in Chambersburg on Route 11. So, you know, your presentation is excellent. I think one question that everybody's wondering, though, since you are NAPA's expert, is what's the next steps, and is there sort of a timeline? And then maybe you could talk about, I think Congress approved a pretty big chunk of money to do some additional research too. If you could maybe touch on that, and then we'll let you off the hook and we'll wrap things up.
Yeah, so the good news is there's a lot of research going on the topic right now. NTHRP had an request for proposals that went out back in early fall. The proposals were due in November, and so I think the panel was meeting this week or last week and this week to try to determine who's going to be running that. But that's a $500,000 process. Our project that's specifically looking at the dry process of this type of material using low polyethylene. So it's a very kind of limited scope. There's an FHWA project that's being completed by Louisiana Tech that is looking at really the binder plastic compatibility and really from that chemical standpoint. So that's another major project that's happening. And the Congress, when you look at the consolidated appropriations bill, there was an $800,000 project that was funded. If you follow it back to where it originally comes from, it was authorized in the Save Our Seas bill, but appropriated in this bill. If I think I got that right, Jay. But the study is actually not going to be specifically research. They're giving the money to the National Academies to conduct this study. And what it's going to be is a panel type study where they get a group of people together that are experts on these types of issues. And they're going to be bringing in people to make presentations about what we know, what we don't know, where we're going. And it's more of a policy type study. And so the one I would reckon it back to that the industry might be familiar with was a few years ago, the National Academies produced that Future of the Interstate Highway document, which was close to 400, 500 pages in length, and kind of said, here are the steps that we need to take when we're looking at the future of the interstate. And so this kind of document will be probably the culmination of this project with the National Academies. So it won't be a lot of necessarily new research, but it'll be pulling people who are those experts together to give recommendations, and they'll probably then look to the path forward. NAPA has talked with the National Academies, and TRB are going to try to actively be involved in that. But that project is just now kind of getting discussed at TRB, and they're learning what they're going to do. We are going to, though, continue to advocate for a research program in the reauthorization bill to focus on this, because this is something that it's going to take time. It's going to take a lot of money. But if we can be a part of that solution, I think it's a great thing. It's a great story. It's a great thing to be a part of. So we're going to continue to try to actually push for more research dollars in that reauthorization. We also may start reaching out to groups like NIOSH and the EPA to help us start thinking about, well, if I'm using this dry, does that impact my plant emissions? And do we need to think about doing some stack testing with this, or look at NIOSH with the health and safety issues? And so we're going to try to spread the wealth with this research and get a lot of other people on board. And I know what's been great is those people who have been doing demo or who are thinking about doing demos, a lot of them have actually been reaching out to NAPA and saying, hey, how can we be a part of this? Is there a question that we might be able to answer? And some of the questions are difficult to answer, such as like the leaching and the microplastics. And but it's really been nice to see the community being willing to be a part of trying to help find out more about this issue.
Yeah, thank you, Richard. If we've gotten, Gary and I have gotten a couple of contacts about some of our members have been contacted about doing some projects and pilot projects, and we're referring them to you as our subject matter expert. And once again, thanks greatly for the presentation. Tremendous amount of information, good information, and this is a hot topic, a very, very hot topic. And the more we can get educated, the more we can get ready to change. So
Yeah.
thank you again, Richard. Appreciate it, and we'll be tuning in for NAPA's annual conference.
Thank you, Charlie.
Yeah, thank you. And we're gonna wrap this up real quick. Just want to say we did get some questions after the presenters. We cut the presenters off, and we're gonna send the questions that were asked during these presentations out to the presenter, ask them to answer them, and then get back to us. And we will email all these questions out to all the attendees. It might take us a week or so to get them out, get them together and get them out, but we'll take care of that. Lastly, I'd just like to say on behalf of the Pennsylvania, the 130 some members of the Pennsylvania Asphalt Pavement Association, thank you for being part of our conference this year. It was a little stressful doing it virtually. It didn't go perfectly, but I think we had great presenters and presentations. Hopefully we don't have to do this again next year, but we've already gotten a suggestion. You got to do it virtually and do it in person. I don't know if Donna and Gary and I want to take on that additional stress, but if you do have any suggestions, how to make our conference better, whether it's virtually or in person, please email me or email Gary or email Donna. Again, I want to thank Gary and Donna for all their hard work, plus also Jill Lombardi, our accounting administrator. She's taking care of registration and all that sort of thing too. So, and information will be coming out probably within a couple weeks on our regional technical, what we're calling a session now. We're not going to have 3 meetings. But we are going to have on the 16th and 17th from 8 a.m. to noon. We are going to have a bunch of presenters and presentations, including PennDOT districts. So with that, say goodbye, so long, stay safe, stay well, and we appreciate your attendance, and we'll see you next year. Thank you.